Hi, everyone. Welcome to day 2 of the Responding to and Investigating Pesticide-Related Bee Kill Complaints produced by the U.S. Environmental Protection Agency. This is Hannah Bartling, and I have the pleasure of being your moderator today. So this is the second day of the 2-part webinar series. Yesterday, we had a full agenda of presentations from experts to speak on topics involving bee biology and health. And a recording of yesterday's session will be available publicly, as will today's, in the near future on EPA's website. So today on the agenda, we'll be applying the information from yesterday to case studies. We'll hear from folks at Massachusetts Department of Agricultural Resources, Washington State Department of Agriculture, and North Carolina Department of Agriculture and Consumer Services. We'll then have a panel discussion to provide more context and hear from experts on their experiences, and finish with our Q&A. Also, please note that the views expressed by our presenters are for educational purposes only and do not represent the official views or positions of EPA or the presenters' organizations. So before we begin, here are a few tips for viewing our webinar. To toggle between a maximized and standard view of the presentation, click on the 4-corner symbol, which is highlighted by the yellow arrow. If you are having technical difficulties, please use the raise your hand icon. It's highlighted with the blue arrow, and we will do our best to help. To download the PDF version of the presentation, press the paper icon, which is highlighted in green. And to pose a question, use the question box, which is shown with the red arrow here. And please note that all participants' mics will remain muted during the event. So we've collected all the questions sent in the question box yesterday, and we'll continue to collect them throughout the duration of this session. And then we're going to present them to our panelists during the discussion at about 1:30 p.m. Eastern Standard Time today. So for the remaining questions that we're unable to address in the panelist discussion, we're going to send out a Q&A document to all registered attendees. We do encourage you to send your questions in the question box as they come up. So now I have the pleasure of introducing Dr. Kim Skyrm. He is the East Director of the Apiary Inspectors of America and the Chief Apiary Inspector for the Massachusetts Department of Agricultural Resources. Kim has worked with wild and managed bees, beekeepers, farmers, and pesticide applicators for the past 17 years through outreach, education, research, and extension. Kim has a bee's eye view of the world and is truly passionate about continuing to do work that preserves the viability and sustainability of bee populations. Kim, I am very excited for you to give us this overview of MDAR's bee kill process and interpreting hive declines. So I will pass the mic over to you.
Fantastic. Thanks so much for having me here today, everybody, and sticking in this. We're going to kick off, I think, another MVP list of speakers, so this is going to be great. I want to share just a little bit about our process here in Massachusetts, and also a little bit about how we've been able to kind of navigate through some of these declines over the years and look at these cases. So I want to kind of set the stage. We've all seen bee data for bee declines, but a little bit different here in the way that we usually start this off when we train applicators and or work with the public into thinking about pesticide impacts on honeybees, is that we always start with some baseline data, and especially for folks who may be new to investigating these bee kills, we kind of need to understand what the environment is out there, kind of what the perception is. So we collect survey data every year from our beekeepers, mostly right through the lens of how the bees survive. So you can see we're pretty average there with the national averages and total losses. And we've got a really good data set from the last 8 years of not only learning about their hive losses, but also asking some basic questions that I'll start with. So one thing that we ask them as part of the survey is, what do they think caused these colony losses if they lost bees? So what are the reasons behind it? And we give them all these different options. We give them a couple more, but most of them don't make sort of a list here. And so over the past 8 years we've done the survey, I give you kind of the range there, the lowest over the years and the highest over the years, and I've ranked them here for you. And you'll see that varroa mites in red and viruses often associated with them. You know, beekeepers are sort of dead on with that as being a big stressor. And you heard a lot about that yesterday, you know, in the bee population. And then we started asking this question about beekeeper management. So you see them actually starting to really take some ownership and awareness around what they're doing and how that may impact the bees. But I want you to notice at the bottom, pesticides ends up on this list. And so this should hopefully kind of set the stage on where you're entering the conversation as an applicator. Is that, you know, it's a little lower, but it is on the list of why they think their bees experience losses, you know, from these stressors. Now, we also ask a different version of this question, and this is where we get a lot of aha in the audience when we share this data, is you'll notice that we next ask the question of what do they think is the single greatest problem affecting honeybee health or beekeeping in our state in Massachusetts. And look at this. We've got our varroa mites there in red. We've got our viruses in red. Okay, great. That sounds, you know, that's kind of what we're seeing. But look where pesticides jump all the way to the top of this list in that range. And so even if they're not sure that it caused their colony losses, they are for sure seems to be dedicated to the fact that pesticides are part of the single greatest problem now impacting honeybee health. So this is where you're going to be before you even get out of your car or make that phone call. This is the you know, where the mindset is, and a lot of people, and you could probably replace honeybees with other things, right? So this kind of just want to set the stage for how beekeepers are thinking and considering these different health stressors. Now the reality is, you know, what does sustainable beekeeping look like? Well, actually, it's a combination of a lot of different health stressors that people need to kind of, or aspects of beekeeping that people need to consider. You know, and all of these different factors you also need to be considering as you're doing these investigations. And I would be remiss without the great Dolly Parton here, bringing her in the presentation and sharing with you that, you know, as she says, we cannot direct the wind, but we can definitely adjust our sails. So as you think about these cases, as you work these different investigations, you really have to think about your work, your actions and the processes that you take, the samples, the conversations, the interpretation, the conclusion of all of these different aspects of beekeeping. And we've heard a lot about honeybee health yesterday from some awesome speakers. And so hopefully you can take from that, right, and bring these into processes. Now, one thing that I will share about our process here in Massachusetts is there's a lot of layers here, but I'll give you just a brief overview. So very similar to the guidance that you heard about yesterday from the EPA, which is fantastic. It is the framework for our process here. You know, it all starts with that initial screening of a complaint that is made, usually from a beekeeper, and we get, you know, we take those complaints. And I usually will do these at my desk, so I can open up Google Maps. I can look and see where the address is to apiary or where the location is. I can look at the weather data. I can, you know, go into our history here and see if there's any other complaints or any other, you know, anything that's happened at that location or with that, you know, active ingredient or that company or whoever. You know, we can sort of create that. So there's a lot of data collection in the front of this. And this should be really similar, from my understanding, to the way a lot of cases are worked at this level of looking at investigations. The big difference here for our state, and other states have followed suit as well, and we've learned from other states who've led the way in this, is that we pair up our apiary team with other collaborators in our department and, of course, in the labs. And this makes a huge, huge difference in these cases. So what we'll typically do is once the apiary team does the initial screen and determines whether it is something that we need to investigate as a bee kill or not, regardless, the apiary team will still follow up on it. But if it does seem to be bee kill related, you know, suspected to be due to pesticides, then we will contact our pesticide counterparts, find out who's available, pair them up with the apiary inspector, go to those locations, right, and then start that investigation process. The big key to this is that we also will mobilize internally our toxicology team, because if we do take samples, those folks are really critical to interpreting those results. They have that knowledge, that expertise, and we're going to need that report if anything comes back with a pesticide hit or any actives in those samples. The other really critical part of this, and I cannot urge this enough, you really have to consider taking molecular samples in addition to your pesticide samples, because if you're only screening for pesticides, you're literally and figuratively getting half of the information for these colonies. And as you heard yesterday, and as I just really briefly showed you, there's a lot of health issues that bees are facing, a lot of stressors in this population. So if you're only looking at the pesticide data from these samples, you could be missing other really big pieces of information that would help you better understand the case, better interpret what's happening for this beekeeper, right? And get them some more information so they can do better management if there's something that they can manage better moving forward. So
Hey,
the rest
Kim.
of, yes.
Hey, sorry, this is Hannah. Do you mind just moving maybe a little bit closer to your mic? We're getting a lot of questions and feedback that it sounds a little echoey and folks are not able to hear you too clearly.
Okay, let me see. Let's try this. How about that? Is that a little bit better?
A little bit. Yeah.
Second here. How about now? I can maybe move it a little bit over here.
Yeah. I think that might be a little bit better. Let's give it a go and see how it works.
Yep, I apologize, everyone. I'm not paying attention here to the chat just right yet, but I appreciate you stopping me here. And I know my accent's a little thick. I know it's not a Massachusetts accent, so I just want to be clear. So folks from Georgia and from the South, is this a little better, Hannah? Please stop me if it's not. I'll be happy to make some changes here.
It's still a little bit fuzzy, but I'm not sure if maybe you have some headphones or anything that you might be able to quickly plug in, just to make it a little bit clearer.
Let me see. Yeah, because I'm using my Yeti here. Let me double check. Let me check on my, maybe Sandy, is there another way I can change my audio? Here we go, audio. Oh, here we go. And then how about this?
Oh, that is so much better.
Oh my goodness. Okay. Yep. I apologize, everyone. It looks like it was not connected with my Yeti. Oh my goodness. Thank you so much. Sorry about this.
No worries, Kim. Thank you. Sorry for interrupting.
Yeah. No. Thank you for stopping me. Oh goodness. All right. So let's get back here. Oh, oh no. Oh my God. This is for real. Oh, here we go. Did that work? There we go. Yay. We're back.
Perfect.
Okay. Oh my gosh, y'all. What a mess. I feel like a total amateur here today. Okay, wrong screen. Okay, so our process here in Massachusetts, again, is fairly straightforward with that, but it really is critical to involve these other groups of folks in your, in these cases, and you really need to make sure that you take those samples for molecular analysis, as I mentioned, and again, I appreciate everyone for stopping. So one thing that we do to help solidify this communication network and collaboration on our end is we do an annual training for all of our teams. So our pesticide team, our apiary team, and our toxicology team, all of them get an opportunity each year to work with each other in the apiary that we manage at the state, learn, go through our processes for the year, and basically show everyone kind of how we're going to collect this, how are we going to do this, who's responsible for what. So if you have an opportunity to do these sorts of trainings, or if you want to participate in ours, I'm sure we can figure out how to make this work. Other states may be doing similar trainings, but there's a lot of valuable information to gain in doing trainings like this. I'll move through here and just kind of share with you our process in investigating these at the state level. As far as pesticides are concerned, right? We've got two different ways that pesticides can impact bees: through this acute exposure, which tends to be like a single exposure to an application, and typically the effects are immediate, or like a chronic exposure, right? Where there's maybe long-term exposure, could be multiple applications over time, it could be a delayed impact. Now, both of these impacts on bees can cause death. They can be lethal. And the sublethal part of the chronic exposure is where it gets really messy. So we tend to, in our program here, and it sounds like in most of work that people are doing, they're looking at these acute exposure, and that's what you're going to see in our work here as well. We're focused on that acute kind of immediate impact. And with the chronic exposure, it really can be a lot more involved. So if you do go down this road in your investigations, just be prepared to look at the individual level. Individual bees are going to be impacted, and then of course collectively as a colony, right, that colony is going to be impacted as well. So you've got to consider both of these different aspects if you're going to go down this chronic exposure for sublethal impacts. So for us, and just kind of a refresher from yesterday, acute exposure symptoms for bee kills, really kind of standard, right? You tend to see a lot of dead bees or bees dying. They could be hairless, discolored, reduction in foraging because the field force is usually impacted, right? We've got a lower population. The bees that you do see, the adult bees, may have funky movements and wiggling, being shaky, wobbly, dying, may seem a little disoriented. There may or may not be a queen in this colony. And then you'll actually see some bees regurgitating material. So you actually can see stuff coming out of them. That's not something we normally would see in this way. And then in some cases, if the colony has been exposed and it's repeated exposure, you may even get a colony that's really defensive. So they may actually be pretty aggressive as you visit them and do the inspection of the apiary. So if you go through and look at these colonies, the first thing you're going to see, right, and we saw a couple photos yesterday of these acute bee kills, is you'll see a large amount of dead bees in front of the colony, typically right outside the landing board or the entrance. And if it's a really severe bee kill, you'll often see bees that can't even make it outside. They'll be dead inside the colony. And sometimes you'll see both of this. And so it can help you if you have an apiary inspector or someone that's knowledgeable with you doing these inspections. Or if you are an apiary inspector doing them, you can really use a timeline and track back based on what you're seeing, how long ago potentially the exposure occurred if you're not sure. So in addition to doing these, and I mentioned a little bit earlier, and I apologize again, the sound was a little rough, but we do pair up our apiary inspectors and our pesticide enforcement team as well. So these inspectors will typically go to the site together, and there's such a great benefit to this, right? Because the pesticide inspector is going to bring that wealth of knowledge and how these cases work and all of those ramifications on the legality of these cases, whereas an apiary inspector is going to really be focused on honeybee health. And so you get that very different aspect in working these cases. And from the apiary inspector's point of view, our inspection starts as soon as we pull up in the apiary. So we literally do from the apiary all the way down to the magnitude and the level of looking at individual cells of bees on a frame. So you're going to get a complete holistic view of the health of not only these hive or the hives in question, but the whole entire apiary, probably the entire operation, just from their point of view. So again, can't stress enough that it's really important to involve an apiary inspector if you're not already in their process, if you have one available, if that's possible. So the types of samples you can take, this is where it gets a little bit more, I think, kind of into the specific information on how to do these cases. And there's a range of stuff you can do, right? You can get anything from the adult bees, right, all the way down to the material that bees are collecting from the landscape. And again, you've heard all about bee biology and health yesterday. So you can get stuff from, the resources they're collecting. My biggest tip here and take home is that whatever you collect, make sure you collect multiple samples of the same thing. So if you're doing adult bees, get 2 or 3 of those if you can. And then also collect enough where you're going to send duplicate samples to 2 different labs. And again, I'm not sure if you were able to hear me with the sound, but we do use a molecular lab for our samples, and we also use our pesticide analysis lab. I'll share those with you later. They're really important to be able to take those 2 different types of labs, or enough samples for those 2 labs, so you can get that complete view of what's happening in these cases. And, again, really important to be able to do that on that molecular level. And again, as many samples as you can get. So if all of these different sample materials are available, I encourage people to take as much as you can, from this colony. I mean, especially if it's in pretty bad shape, you're getting a lot more information. As far as looking at sampling, and if we go down through this fairly quickly, so adult bees, it's kind of straightforward. You can get them from the outside of the colony if they're expired, on the landing board, and these piles of dead bees, you can get them inside the colony. You can also get the adult bees that are live. I do highly suggest people to take samples of live bees because it's a good reference point for you to have if you can get dead bees as well. If they're available, and or dying bees, those are also good to have because they're probably the most fresh as far as the impact. And you can also take brood samples. So there's a lot of conception around in the beekeeping world that if bees are exposed here, you can see these pupae in the cell where their tongue is exposed. A lot of people will immediately say, oh, that's had a pesticide impact because the tongue is exposed, and that means they have died from pesticide exposure. So you may get a lot of those phone calls, so collect them, take a sample of them. The other type of sample that you need to really consider, if you have the bee material to do it, if you have enough adult bees, preferably live, but you can also do this with dead bees, with a little bit more caution here in how to interpret it, but you need to be taking a varroa mite sample. And I'll share with you a little later why, and I think Emily did a great job sharing that with you yesterday, and I'm sure we have a couple great presentations that'll also share the importance of this, but it really gives you an indicator on not only the amount of varroa mites that are in your colony, but if there's any other issues that come from having varroa mites, you'll have a really good bit of information here to back that up, why you see this virus or you don't, or why this may have happened. So really important, we always try to take a varroa mite sample when we can in these cases. So in sampling the rest of the colony, if you've got frames, right, hopefully you've got some of this stuff still left in the colony. If not, we had a couple of great examples yesterday of problems that can happen that aren't bee kill related, and I'll touch just a little bit on that at the end. But wax is pretty self-explanatory from the frames. In the center here, you've got bee bread and pollen, so a little bit different material, but and then of course on the far right, we've got our nectar and our honey. So I just want to caution you, whatever you decide to take that is available, hopefully a little bit of everything if you can, but be mindful that, in this case, if you're taking a sample of pollen and bee bread, in this case, bee bread, that if you cut out a piece of comb, make sure that, you can see some larvae and adult bees here. So if you get other organisms, other types of samples in your sample that you're not attending, that could impact your results. So just be really mindful about what you choose to take. And of course, label. Make sure there's a lot of documentation, photos, your notes, everything that you're taking samples from. And then just a little bit of information about how to collect samples. So there's a lot of material out there. I'll leave you with 2 tips here. The first is, whatever you intend to go to a pesticide lab, make sure that it will not degrade in process, either in storage or in transit. So you want to use amber here, you want to use aluminum foil, whatever you got available. And of course, in the pesticide world, y'all are experts at this. But if you're new to this, make sure you're looking for material that will not degrade any chemicals in sunlight in your processing or storage or transport. And then, of course, maintaining a chain of custody when you collect samples with you and your department, and also with the labs, whoever you're sending them to. And there's, of course, just tagging and making sure you're bagging everything correctly. So there's a lot of standard and protocols here that you're probably already doing that will very easily transfer over to bee kills. And the last little tip here is, when you go to a bee kill, this is one that we did a couple years ago, sometimes you got to make sure, right, you're looking around, because if you stay focused on these colonies, which is what we went to do a bee kill of, you're probably going to miss, you see these 2 colonies here. We've got a couple of different adjoining pieces of property here, but you'll totally miss this swarm that's right in the middle of this tree that was also impacted. So just to be aware that, depending on the time of year you do these cases, you need to be aware that there could be other things in this space that you need to sample, or at least consider as part of your process into these cases. So, we had no idea this was going to be there. And so you got to be quick, think on your feet, and be ready to take some samples when you need to. Now, the labs that you can use to process the samples are readily available. And I want to note that beekeepers can also use these labs. So if you have a case where someone really wants you to do an investigation and you're not able, or for whatever reason aren't going to take samples from the case, you're not going to do that, you can instruct the beekeeper to contact these labs, and they can actually process their own samples, if they want to do that or follow up in the future. So, but we do here at MDAR, we use the National Agricultural Genotyping Center lab that's in Fargo. They have a really broad range of pathogens they'll check for. And then we also use, which is really exciting at the bottom, the Texas A&M lab for our pollen and honey samples. So this is a really cool resource available to you, especially in your investigation. So say you go out, you're not sure what happened here or who sprayed what, or even if anything was sprayed, and you get a report of a bee kill and you get samples that you take them, you go through the whole protocol, and they come back with a hit of something, there's an active ingredient in there, and you have no idea where it came from. Well, you could actually go back in your samples, and if you've taken enough, you could send a honey or pollen sample off to this lab, and they'll tell you what plants are in that sample. So if there's a chemical, if you found a pesticide in the sample, say for instance in the honey, they can give you some indication of what it may have been applied to in the landscape. So it's a really important piece of your investigation, right? If you can backtrack what may have been part of the application, if there was one in this case. So here's an example of the NAGC lab. You can see all their different material here that they'll detect, they'll look for in the samples. It's quite a comprehensive screen, and it's usually pretty speedy. So if you need this information, you can find it on their website. But we very much have really enjoyed being able to use this lab and have totally changed the way that we do bee kills, having access to this information. So I'll share with you our local lab that we use for pesticides is our state lab. So they will typically do what we refer to as a bee screen, and it includes 94 different chemicals. And what we like to do when we can is we like to target the screen. So if you have a case where you know something has been applied and you want to see if that was what impacted the colony or colonies, you could just target the screen, to that active ingredient. You don't have to do this entire comprehensive bee screen kind of, full screen panel. You could just do that active. So those are ideal cases. It's much quicker, it's much more efficient for everyone, and I think it's a lot easier in these cases. But right, it's not always that clean. So if you need something a little bit more comprehensive, your state may also have a bee screen, or there are a couple of the other labs I showed you on the previous slide. They'll do a large panel screen for you and look for everything. So here's the pollen lab, just their information. It may be a little hard to find this lab on the internet. They had a little change in personnel, and so if you're having a hard time contacting them, definitely look in your handouts from this workshop, and you can grab this contact information and the address here to send samples. So I'll just caution you on this one, but it's a really cool service. Can't recommend it enough. And then finally, what are the results? We always get this question. People are kind of on the edge of their seats, like, okay, you've done all this work, you've done all these cases. Well, typically we get about, you can see here in the blue, reports or complaints, about 20 or so a year, give or take, and then we investigate those, which means we consider them to be a potential bee kill related incident. Typically about a quarter, sometimes a half or more of those, but generally a much lower number because of the other things that I'll show you in the next couple slides that ends up happening in these cases. And you've seen a lot of, again, photos yesterday too of all the health issues that bees face. And then at the bottom in green, you'll see those little teeny numbers are the ones that actually resulted in pesticide-related bee kills. So they were found to have an active ingredient and suspected to be concluded as a possible cause of death in those cases. So I'm going to show you now what happened, like for instance in 2022, what happened to the other 18 of these cases. So I'll give you an example briefly. Majority of the kills that we get for complaints and or through investigation, you can typically see what you saw and have seen in these photos and videos through visual inspection. So weather related, winter dead out, flood, something of that level. Starvation, we have a really big range here in forage availability in our landscape, unfortunately, across the board. So this can really impact bees, and sometimes rather suddenly. And queen issues, another real big problem we see, and definitely something that's really hard sometimes to navigate, but pretty easy to see in visual inspection. And then molecularly, as I mentioned earlier and a couple of times, we have such a great benefit here to be able to have molecular data, and has been just wonderful to help us figure these cases out. So typically you'll see stuff in there, varroa mite related viruses, and as I mentioned, like the mites themselves in an alcohol wash. And then some of these viruses that you'll see listed here, and I'll go into a little bit of detail in each slide here at the very end of this. And then finally for bacteria, we have seen pretty rarely, but we have had a couple cases over the last few years where American foul brood could have been the culprit or was the culprit of the suspected bee death. And then I'll leave you with this, and it's never, fun, but it's honest. Sometimes we just don't know, and that's okay, because it's really, beekeeping is difficult. And as you glean, right, there's a lot of health stressors that bees face. And so it's not very easy sometimes to figure out these cases if you come up with samples that have nothing in them. So you kind of may be left with this unknown category, and just be aware that, this may happen, and that's okay. That's part of our job, is to try to do as best we can and work in these cases, being supportive to our stakeholders and getting as much data and information as we can. And sometimes we don't know. So I'll leave you with that. So let's talk about weather-related bee kills. So this was an example from a winter dead out. This was in the spring. We got a phone call of a bee kill, and yeah, there was definitely a pile of dead bees. This colony was perished probably several years prior, to be honest. There was not a lot of activity in here for a while. This was a property that someone had a vacation house, and so they had not seen the colony in a while and came back after a period of time and suspected, right, that the colony may have perished due to chemicals. But it was so degraded, there was no way you could get a sample, and quite frankly, this did not present at all any symptoms of a bee kill. But you can see here our toolbox with our materials and our amber jars. So there's a weather one. The next one I'll show you a slide of is starvation, which you've seen a couple different versions of. I'll play this video clip here for you. Let's see if it'll work. Well, it's a little shaky, but the idea here is that you've got, and you saw some videos as well yesterday, very wobbly, very lethargic bees that are barely moving. You actually see them dying on the frames. This is not an active colony. They literally have no resources in here. So I know they did a great job yesterday showing photos and videos of this. So the next thing that you will often see in these cases could be queen related. And in this case, we do see dead bees on the bottom of the ground in front of the colonies, but there was no brood and very little food and a lot of signs here that this had been queenless for a period of time. So, it definitely looked like that they had a health issue, but it was not to be related to pesticides, at least not from our investigation of these. So, if you're seeing something where there's not a lot of brood, there's food that has been taken from the colony, these are actually robbed out. They were so weak because there was no brood, there was no bees. You can even see some signs here of robbing on the frames, and I know there was a few photos of that as well. So what we really get to see a lot of in these process of looking at the molecular data, and again, which has been really cool to get the results of these because it helps us instead of the scratching our head with the unknown, are cases like these, the next couple I'll show you. So this was a call we had where someone had several colonies that were near their garden area, and there was just dead bees everywhere. I mean, there was 3 of these colonies, and the amount of bees on the ground was unreal. I was shocked there was any bees in the hive, but they were dying while we were there, and it was obvious that something was happening in these colonies. And so we came and took a couple samples, took a lot of videos and photos. And what we noticed is, and again, I can't stress enough the importance of photos, is when I got back to the office, I started looking at some of these photos because, like I mentioned earlier, the beekeeper said, well, I've got some pupae that have their tongues exposed. So I know it must be chemically related. So we took samples for pesticides, we took samples for our molecular lab, and I kind of have the results here for you. But the pesticides came back with nothing in the screen, but our molecular results were interesting because, and I couldn't figure this out because again, I was doing this to get samples to the lab as quick as possible. But when I started zooming into the photos and I got back to the office, you'll notice that a lot of these adult bees on the frames had varroa mites that were visible on their thorax. I mean, look at this, 2 on the abdomen. And this is pretty strange. And a couple of folks have mentioned it before. When you see varroa mites to this level, there can be usually much bigger health issue. And you'll notice here with the alcohol wash, it was huge, right? The threshold for varroa mites before we recommend a treatment is 3 to 9 mites, 3 to 9. Look at the number here, everybody. It was huge. So it was phenomenal to me that this colony was even as thriving as it was, much less that there were bees still left inside the colony with so many dead outside. And then when the molecular results came back, we found out that they had Israeli acute paralysis virus, which, and I know there was mention of these as well yesterday, but these viruses that cause paralysis condition, right? Bees to die, bees to exhibit abnormal movement, in this case, actually killed the colony. And since this time, we've been using molecular data, and we found this happens a lot, believe it or not. These viruses end up being the cause of a lot of what look like pesticide-related bee deaths. So good news is the colony did actually rebound. The beekeeper got into this and managed really heavily, and they were actually able to pull it through the winter. I do not know how it's doing today, but I do know it made it through the winter. But, again, very interesting case, and without that molecular data, probably would not have been able to figure this one out. So another good example here, and it's a little faster for you, is that you see a huge amount of dead bees on the ground in front of these colonies, huge. And this is another good example of a virus. This is Lake Sinai virus 1, another virus that can cause problems with these honeybees that looks like an acute bee kill. Look at all these, dead bees are everywhere. And these colonies are very weak. There was not a lot of individuals. Actually, you can see our girls are getting robbed here. They're so weak, and there's so many bees dead and dying. And nothing came back in the pesticide screen, but in our molecular analysis, we had very high levels of Lake Sinai virus. And again, we see this, and we see Israeli acute paralysis virus causing what seem to be very visible symptoms of a pesticide-related bee kill. Well, that's not all, and I won't spoil the next bit of our show, but we have other cases where we've looked at, again, a large amount of dead bees, looks like an acute bee kill, looks like something's happening. This is probably one of my favorite viruses, and also one of the trickier ones in some ways to diagnose, in the sense from looking at the molecular results. If you don't take them, you may not notice it because it presents very, very similar to a pesticide-related bee kill, probably the most identical of all the viruses that looks like a pesticide bee kill. And I'll show you why. So if you look on some of these, the images here, it's a little harder to see, but a lot of these bees look black or hairless or greasy. And you're thinking, well, it could have rained, maybe. They could have got into nectar, maybe. But if you go to the next slide here, you'll notice, and I'll play a little video here for you. It might be a little wobbly, but you'll notice very lethargic bees, barely moving. You know, these individuals are even trying to help clean themselves and feed each other, but you can see a lot of dead bees. You really see these these dark, greasy, hairless looking workers. And if you look in this slide, right, this is inside that colony. Look at this bee. This is what it looks like up close. So not a lot of hair, very darkly colored. This is what it looks like when you get one version of chronic bee paralysis virus. And again, probably the most tricky as far as if you don't take molecular data, you wouldn't be able to know, because it really does look like a bee kill. Because oftentimes if bees do get in contact with chemicals, you will see them groom themselves almost to look like this in some cases to try to get that off of, whatever they got into to get it off. But this virus specifically very much looks like a bee kill. So again, please make sure you take that molecular data. And then here's an unknown just for fun. So I don't know if this is fun, but just to kind of help you, well, a little harder to see the videos, but there are bees kind of dying, weird behaviors, spinning, wobbly movement, jerky, lethargic, all over this apiary. These were new packages that were installed, so they were barely in these boxes a couple of weeks. And this was kind of a head scratcher for us. We couldn't figure out what happened. There was no chemicals in the screen. The only thing that came up in our molecular screen was deformed wing virus, but it was at pretty high levels. So could have caused the death, not really sure. But regardless, something's definitely happening here in this colony. So this could be a good example of an unknown one for you. And I'll leave you with probably the most scary of all the things in beekeeping. And I know we're out of time, so I want to make sure we at least show you this one. So this was fresh, literally from last week, very hot off the press here for our data results. We had a case that we were working where it was suspected to be due to a bee kill, and actually it was due to American foul brood, which is a bacteria that bees get. But you can see this is a colony here in question, not a lot of activity at the entrance, kind of tall grass, but look how large this mound of dead bees is, compared to where the colony entrance is in size, but also how far away it is, right? Typically our bee kills due to pesticides or acute kills are right outside the entrance, but this is pretty far away. So, we took a sample here for our molecular lab, and you'll notice that in those sample results, we did find American foul brood, not European foul brood, but it could also be really similar in presenting in the case. And when you open up this colony, you can see a lot of the cells here. I mean, if experienced beekeeper or anyone in beekeeping probably automatically goes, ooh, something's going on in this frame. It does not look good, very sporadic development. And I know you had some information on this bacteria yesterday, but from the swab samples that were taken, definitely was found to be American foul brood. So, something that can kill bees and definitely can kill them over time, can also kill them fairly rapidly depending on the level of infection. So that's all I have, everybody. Thank you so much for your time. Here's my contact information if you have more questions. Always happy to help people navigate these. Definitely don't know it all here in Massachusetts, but we've seen a lot of stuff over the years, and again, always happy to be supportive. So thank you so much for your time today, and again, for your patience with that sound issue. Thank you.
Thanks so much, Kim. And also, folks will be hearing from Kim later in the panel discussion. But thank you for your presentation. It was really interesting hearing about the similarities between viruses and bee death, and also the importance of submitting molecular data kind of to differentiate and assist in your interpretation. So thanks so much, Kim. Okay, so next up, I would like to introduce David Bryson. David was a beekeeper with over 3,000 colonies in California during high school, and while completing an agricultural biology degree at Cal Poly. He has a Master of Science from University of California, Davis in Plant Protection and Pest Management, and was a postgraduate researcher for University of California Extension. David was a former technical sales representative for a pesticide distributor, a licensed pest control advisor and applicator, and a study director of rodenticide field and laboratory studies. He is the current senior specialist at Washington State Department of Agriculture and has worked there for almost 12 years. David, I will turn it over to you to talk about some case studies on pesticide-related bee deaths.
Okay, thank you. Thank you for allowing me to participate in this webinar. And I'm going to give a little bit different perspective, more so from my pollinator perspective. And yeah, I did run 3,000 hives of bees, and a lot of the time we would participate in the almond pollination in California. I was based out of Southern California, and we'll go into that a little bit more. So yesterday we got a lot of information on the baseline and what actually makes a strong colony, what to look for all that. So I won't go over a lot of that detail right now. So basically with pollinator contracts from that standpoint, they often specify the number of frames that you have to participate there. They're a little less picky right now because there's so many hives needed out there, basically. We're looking at contracts asking for a requirement about 5 to 8 frames of bees, covered with bees, about 75% of the frame being covered. And right now we're looking at basically 1.38 million acres of producing almonds in California. And if you look at 2 colonies per acre for pollination purposes, you need a heck of a lot of number of bees, about 2.8 million colonies of honeybees, just to take care of that. And if you look at the numbers of what they project are actually in the United States as far as colonies go, I'm sure there's quite a few out there that aren't counted as far as hobbyists, et cetera, but it's about 95% of the colonies that are in the United States. So what do you have? You have a large number of bees going to a very smaller area all at once and being staged there. So keep that in mind as we move forward in this conversation. So it's basically the Super Bowl of pollination for honeybees. A couple of facts here as far as the number of, there's 3,500 cells per side of a full depth of a frame. And this is your standard frame. And so you could give that a little bit of judgment how many bees are on a frame too, if you're an inspector or going through and looking at the hive. Nectar and honey, basically you look at that, that was handled pretty well. Emily Wine talked a lot about that, the math of the hive itself, and pollen and bee bread, what's available there. See that. Okay, so a balanced brood chamber. Eggs, basically 1/3 each for that. Get into that. A population of egg to pupa stage, 1/3 population are pre-foragers, and 1/3 of the population in forager stage. And this is spring to summertime when they're really active. Okay, so we went through this a little bit yesterday too, so I won't dwell on this too long. Period of service is a house bee. You see the number of days here. And this will help you keep in mind what's going on in the hive too as you look at it and do the inspection. Okay, so this is another piece of information that helps out. I pulled it from Karen and Connor's book. Crop attached bees, basically a good source for foragers to go back and forth to a fixed forage area. And crop attached bees, poor source foragers going back and forth to a filling or unattractive site who may wander and search for new sources. Keep this in mind as we go forward here. As the pollination of almonds takes place, and it's almost over as far as the bloom goes on the almond trees themselves, the bees are going to have to start looking for new resources. In California at the time, of course, there are a lot of things blooming out there. There's mustard crops, etc. But not in some areas where there'll be a lot of resources available. So they'll need to go as far as they need to go to find that new, basically resources, especially if they aren't being fed at the time. It's Scout bees actually look for new resources of forage. And then there's the unemployed forager bees, not active in flight or active for only part of the day on a limited flower source. So this also is information that if some of the foragers are out there and going out to, let's say, a parathion spray, as we used to be able to use more so, but a pyrethroid or whatever that might knock them down quickly, those scouts may not make it back. But even with, as we'll find out, even with some of the more toxic chemicals, they may be able to make it back and do a dance and tell everybody else where the source is before they have symptoms. Okay, I had a...
Oh, David, you can use the right or down arrows.
Yeah, it stopped working for some reason. I can't advance it.
See, maybe if you try left clicking.
Yeah, I'll try it again.
Might be a little bit of a delay.
Okay, no, not work. There we go. Okay, so pesticide exposure. If foragers hit by highly toxic pesticide and fail, usually they recover. But even parathion could be taken back to a hive. And I know parathion's not really used all that much anymore, or not at all in orchards, etc. But this is a good example from the OPs and carbamates, what took place in the past. We still see certain toxicants out there that can knock down bees right away. And certain pesticides in pollen or nectar may be at high enough concentration to kill nurse bees larvae, resulting in colony not being able to recover. In the past, when I was a beekeeper back in late 70s, early 80s, PinCap M had pretty much been discontinued. Everybody familiar with methylparathion in an encapsulated formulation. And what was taking place is the bees were out gathering pollen, and the PinCap M would be in the pollen. And the bees would take it back and feed it to larva stages, late larva. And basically it'd kill out your whole hive, but you also have a residue of that. And you couldn't use those supers. You had to basically destroy all the wax, honey, et cetera, in that at that point. Okay, this is the incident back for the pollination experience. Basically, there's bee brokers out there for the almond pollination. And these persons are very instrumental in keeping bees safe too. Joe Trainer, I used to work with him back in the late 70s, early 80s. And he's a crop consultant there as well as basically a bee broker. And I pollinated Tejon Ranch Company, which is owned by the LA Times. And he would set it up, tell me exactly where to deliver the bees, and make sure that the Tejon Ranch wasn't making any sprays that would bother the bees or harm the bees. So he related this one, which fortunately didn't hurt my bees at the time, but he had a personal experience learning about the flight range of honeybees. So we're going into the flight range, and he saw poisoning by parathion. What was happening? All the blossom was done in the almond crop, and the bees were moving to nectarines, and they were about 2 miles away from most of the bees. There were approximately 5,000 bee colonies on 2,500 acres of almonds, located 2 miles south of about 200 acres of nectarines that were in full bloom. The poisoning occurred at the tail end of the season for the bloom. Basically, you saw that the bee kill pattern in the almonds conformed exactly to the distance from the nectarines. The closest bee is a little over 2 miles from the nectarines, so it's quite a distance, showed a severe kill, while bees 4 miles away suffered what would be considered a light kill. So we go back to the ones going out further and foraging might be knocked down before they make it back to a hive. And from this diagram here, you could see generally out 2 miles is considered a limit bees will fly to explore their area. Well, they could push it out quite a bit further if there's no resources around, and will do so. And so we saw that out at 4 miles, they were still receiving some kill. That's one thing doing an investigation you have to keep in mind too. What are the resources around the area where the bees are at the time? as far as resources, meaning what's in blossom at the time and would have a nectar flow that the bees could feed on. Okay, so this is sort of the law of diminishing returns. It applies to bees too. Looking out at 0 miles from the actual hives, they could get about 25.3 pounds of weight over 18 days in this experiment anyway. And if you go back out to about 4 miles out, you can see that it's about 5.1 on the average of honey per day. So as you get out further, it's a law of diminishing returns, and it goes into the negative portion where they're expending more energy to go out and actually harvest the nectar and bring it back to the hive than they're actually able to get any type of savings within the hive of the honey itself as far as the reserve goes. Okay, so this is a case study I'm going to show you. Carl Henriksen, one of our investigators here, I sort of looked over his shoulder during this investigation and helped out and set it up. A lot of samples were taken for pesticides. We do not do sampling for viruses, etc., in our current pesticide inspections. Okay, so the nature of the incident when it occurred. So May 27, 2020, beekeeper called basically WCA to file a complaint. So he believes that pesticide involved because he had visited the bee yard on May 10 of 2020. So we're looking about 17 days earlier, and everything looked good. May 27th, he visits the bee yard, and he sees dead bees and abnormal behavior exhibited by live bees. So talking another 17 days out there, he comes back and is pretty much devastated. So the WSDA compliance investigators went out May 28, basically gained the history of the colonies, what took place. The hives taken from Washington to California for almond pollination and remained there until the end of March. So I went there, staged up a little bit, fed some sugar water, tried to build up numbers so they passed the test and being able to be used for pollination, and gained the whatever the price was. We didn't actually ask that one, but could be up to $200 or more per hive paid for the pollination services in almonds now. Okay, April 1, the hives moved to Apple Orchard in Washington for pollination services there too. Okay, so we see April 27th, varroa mite control by tactic. Ooh, so not registered, performed while in the apple orchard. He saw a problem, decided he better treat. Treatment took place. Of course, like I mentioned, not actually registered, but he obtained it from the internet, was able to get it for that purpose. Okay, so he put it on paper towels and put it into the hive itself, the first 2 supers. And his dilution rates weren't great, but here's what we see here. And within the hive itself when we investigated the bee kill. Okay, so the varroa control is due to push of colony growth to meet requirements for the pollination. A lot of times it ends up with a lot of stress. Paper towels on tactic and corn oil is what he used as a carrier for the tactic. Beekeeper noticed problem he reported on May 27th. Okay, so this is the area that needed to look at. Okay, right next to the colonies down there where it says beehives was a squash field there. And this is organic, and it had just been planted, so it hadn't emerged or anything at this point. The Timothy, it was too early for that to come up, and all the stuff that was green around that area would not be green yet. You can see there's a little drainage area, and there was a bit of water down there. It was not greened up at this point, but there was water there. The beekeeper did not have water available in the bee yard, so the bees were going down there and drinking too, which can be a problem. Okay, pesticide use records were requested of the beekeeper and growers around the area too. Basically, what had been applied at that point was BT for mosquito control, not a problem, and herbicides. Squash crop, the bees are on to pollinate. Wind and Bloom is being grown as an organic crop, and like I said, the crop hadn't even emerged yet. It was organic. So come up with a sampling plan. In this case, we did a heck of a lot of different samples. Wanted to get information on what was in the honey, what was in the wax, and even some of the older wax, which may not be the normal way you would do it for an investigation, but wanted to see what all they were exposed to. Okay, so unfortunately, before we got there, some of the hives have been combined, complicating the investigative process and making it real rough to figure out what actually took place. He wanted to say what few were actually living at this point. Okay, some of the detections came back, what hits we did receive after taking the laboratory. Live bees that were sampled, 3 samples. Amitraz showed up, which he had used, tactic. Buprofensin at 5.6. None of the levels were anything that put up red flags. Dead bees, buprofensin a little bit higher, but still not a red flag there. Some of the fungicides, of course, some of the silicate carriers that they use in putting out some of these fungicides can be a real problem to bees too. We don't typically actually try to do an analysis for a adjuvant of any sort in Washington State, so we don't get information on that. And silicate would be hard to test for anyway, since it occurs in the environment anyway. So here are some of the results overall for the swabs of the hive exterior. This is interesting. Carbendazim and diuron can be found in paints too. They're added not as a pesticide, but as an additive for a preservative, and that's legal to do for the paint industry. So you can obtain that sometimes by taking swabs from painted materials. You see quite the, these are all used on almond production, except of course for anything that is used for the diuron and such wouldn't be for that in the paint. Bear with me, I got a delay here of some sort. Okay. I'm not advancing again, unfortunately.
No. Are you using the keys or the mouse to click?
I'm using the keys.
The keys? Yeah, I would try moving your mouse into the left hand corner, bottom left, and try to click through.
Yeah, not getting anything there.
No response.
No response. Let's see.
Maybe our friends at the Center for IPM could help us advance. Sorry, folks, bear with us for 1 second. There's a lot of people on here today, so having a little bit of delay. Oh, there we go.
It was a long day. Sorry about that.
Yeah, a few clicks.
Okay. Yeah, sorry for the delay. I'm not sure what's happening here. Okay. Almost back. Sorry about that. Now it's working. Very good. Okay, so the swabs of the hive interior showed us the amitraz there, which would be expected since the tactic was used. Buprofensin Again, a little bit of that, not something that's going to be a problem probably. Chlorothalonil, and the diuron was inside too. Talochlor and trifloxystrobin, which is a fungicide, of course. And as far as the swab of a single frame, you see the amitraz is pretty heavy, with profazin, trifloxystrobin on that also. So there's a lot of stressors in there as far as different chemicals, etc. But the big problem was actually mites. He'd done the Varroa treatment when there was capped brood in there. Most of it was capped, and it did not actually take care of the mites. They later came out, and you can see that a lot of the problem was due to mites. A little bit of tactic problem too, probably. Conclusion is the multiple stressors may have affected colonies, but their management resulted in their declines and their death. So unfortunately, it was just a matter of part of it was starvation. In actuality, he didn't keep up on what was taking place around the area. There weren't very many sources of nectar, if any, around that area. And he was ready to feed again, but hadn't gone out there to check to see if they needed to be fed. And most of them starved to death or affected by mites. So if you have questions, go ahead and submit those to the end. And thank you for your time. Appreciate it.
Thanks, David. Thanks for providing that perspective from the commercial beekeeper. I liked how you called the almond pollination the Super Bowl of pollination for bees. Okay. So our next speaker is Travis Snodgrass. Travis is a pesticide specialist for the North Carolina Department of Agriculture and Consumer Services in the Structural Pest Control and Pesticides Division. He's worked for the department for 16 years, first as a field pesticide inspector before being promoted to the pesticide specialist position in 2021. Travis is a former commercial greenhouse grower and manager for 6 years, and he holds a Bachelor of Science in Horticulture from Virginia Tech. Travis, I will turn it over to you. Let me try to, there we go.
Okay, thank you. And I appreciate this opportunity to be able to, share some of our experiences here in North Carolina and some of our, bee kill experiences that we've ran into here in the past. So like David said, he was doing it from a perspective of a beekeeper. And I'm going to talk about this, at least talk about some of our case studies that we've ran into from the perspective of an actual pesticide inspector going out into the field. Okay, here in North Carolina, and I think it's been mentioned by a lot of our speakers already, we do a co-investigation for all of our bee kills. We have all of our field pesticide staff that goes out and actually does the investigation from a pesticide perspective. And we also work with our state apiary section and their staff. There's 6 of those on staff. And we do a co-investigation with them. So we will go out, maybe with our state apiarist, Don Hopkins, and Don is there on our, in the bottom right picture, and he's going to look at it from a beekeeper perspective. So we always like to say Don is kind of our bee whisperer. That we always say that the bees know Don, and we use him or any of the apiary inspectors as a almost like a canary in a mine. To where if they go out there and if I see him with a veil on, I know it's a serious bee kill. That they're very mad and they're very upset. And then, on the left-hand side, our field inspectors, they will know the crop in the area. They will know the practices, the farming practices. They more than likely know the grower. They'll know the pesticides being used, the timing, the crop timing, the workers, the applicators. That's going to be their area of expertise. So we combine the two in all of our bee kill investigations. And I think it was mentioned yesterday about the EPA bee kill investigation guidance. So we did our own little worksheet, taking the old pollinator protection worksheet and kind of made it our own. And this is available, and I'll talk about this at the end. with our bee kill videos that we've done. But our pollinator protection worksheets, we've got that split up into a pesticide inspector check sheet and a apiary inspector check sheet. So they're going to go out and look and see, the magnitude of the loss, colony history, the food stores, the varroa mite count, whereas the pesticide inspector is going to go out and look at it from what pesticides were applied, by the beekeeper, what pesticides were applied in the immediate area, what was the stage of the crop that was being grown, were the bees present there during the incident. So, and then what I'm going to do now is just go over about a half dozen of our case studies that we've got. So here's one that we had, and this was way up in the mountains here in North Carolina. And it was actually during the late summer time frame. So it was right after our sourwood flow. So we had a pretty good dearth, and we got a call from a beekeeper, and he said he had about a half dozen hives and they were slowly dying. And he said every day there's more and more dead bees out there. So our apiary inspector went up there and took a look at it and pulled a pretty good sized sample, and our beekeeper pulled a very large sample. So by the time that we got up there for pesticides, there wasn't a lot of dead bees left, but we had enough to where we could pull a sample. But from the pictures that we saw, that there was a significant amount. In fact, you can kind of see, where it's a little wet right here, and that's where the dead bees were all piled up before we got there. So we went and talked to the beekeeper, asked them what was applied in the area, and you can kind of see it was in a daylily garden. So, they told us that there was no pesticides applied in the daylilies. It was more of a hobby type of thing, that they were a collector of, these unusual daylily varieties, that they like doing breeding on them, but we were assured that there was no pesticides being applied. The second thing we looked at was the water source. So right below the beehives was the water source for the bees. And you can see they had this nice little waterfall there, collected water during the summer. The spring was way down. It wasn't running very much at all. And it was just a big puddle of water there at the bottom of their water feature in the water garden. So we asked them, I said, are they using, any type of mosquito control in this? So we were assured that they were not. So we expanded out our search, started driving around the area, and up in that particular area of the state, we have a lot of hemlocks. And because of the hemlock woolly adelgid, that if you see any hemlocks in the area and they're green like this here, we know they've been treated. Otherwise, they would not be alive at that particular point in time. So this was during in a very nice development area, and it was just miles and miles worth of really nice, trimmed up hemlocks. Started looking at it and noticed a lot of flowering bedding plants, just below the hemlocks. So we went and talked to the homeowners association, talked to them, find out, were they being treated? And so, the obvious answer was yes. They gave us the name of the landscaper that was treating them. And then we went and talked to them. But before talking to them, just kind of looking at the bedding plants underneath it, I mean, it was just bee after bee after bee under it. We had no problem finding the bees. So you can see they were foraging on the bedding plants. And this was during a dearth in the late summer after our sourwood flow. So they were really struggling trying to find anything. I remember talking to the apiary inspector at the time saying, what are they foraging on? He said, basically anything they can find. And you can see just in this picture alone, I mean, I see 3 or 4 honeybees, I see a bumblebee there, all over there foraging on this. So talked to the landscaper. They used a high pressure sprayer. So obviously they were not doing a trench application around the hemlocks. They were not doing a basal treatment. They were not doing a tree injection treatment. And what I'll do is back up here, see if it goes up, and you can see the angle, and you can see the truck at the bottom right. You can see it kind of comes up on a hill. So the way it was explained to us that the applicator stood at the bottom by the road going through here and just sprayed the hemlocks from both sides. So naturally, it was very difficult for them to spray that and not get it on the flowering bedding plants, especially using equipment like that. They were running 300-400 PSI, and it was just, they were hosing down and just treating everything in the area. Talked to them, asked them what they had applied. They had used Safari. So that's dinitrofuran. So it's a neonicotinoid. It does have the bee label language on it. We pulled samples. We pulled pollen samples and the dead bees, and they both showed the presence of the active ingredient, along with the target vegetation sample. So the flower and bedding plants, that showed the presence of the active ingredient as well. And the apiary inspector could not determine any other issues with the colony. So, naturally there was a label violation, do not apply to plants that are flowering. All right, case study number 2. So here's one that we had going out, and I'm a beekeeper myself. So I've been a beekeeper for a little over 10 years. And I always like to say that my experience in beekeeping is kind of limited to my science experiment in the backyard. So I know enough to be dangerous, but I don't know enough to be able to diagnose certain bee issues. So naturally, when I got this call from the beekeeper, they said that it's all the larvae, all the pupa in the hive is just being pulled out by the bees. They're all dead. First thing I thought, being a beekeeper myself, was, it sounds like chilled brood. But we, fortunate enough, had a colleague of mine in the apiary section, Lewis Cobble, came up, looked at it, and he ruled that out immediately. And it was just a big pile of all of the larvae, all the pupa, everything in that hive was just cleared out. Pulled out the frames. All of the adult bees were just fine. They were there. They were happy as can be. In fact, we were able to find the queen. The queen was alive, and the queen was actually still laying eggs. But every bit of the larva, every bit of the pupa, anything that was uncapped had been cleared out by the colony itself and just thrown out onto the bottom board and then been pulled out. And it was just a really nasty mess. In fact, our lab personnel, they probably didn't like me for months after that, after I collected that sample, and it just, it stunk. It, a few of them are still wiggling. So I was, took that in and dropped it off at our lab and had it analyzed. Well, we started looking around in the area, talked to the beekeeper. The beekeeper had not applied anything. The apiary inspector had actually ruled out chilled brood. In the area, we started expanding, and a half-mile away was an orchard. So naturally, we went over there and talked to the grower at the orchard. And the first thing we saw pulling up is the nice big air blast sprayer. So, naturally pulled in, saw that sitting there, and knew that they had applied something fairly recently and applied something, where they got it all over everything. And in fact, I knew the apple grower, a really good grower, does a really good job on records, does the best he possibly can on a lot of the stuff. So we went, checked around the orchard. Most of the stuff was not blooming. He did a really good job. He tried to do a good job on bush hogging and mowing between the rows of trees, but you can kind of see some of this yellow clover. And that's where the bees were foraging on at the time. So we were able to see bees. It was very easy to see them. We walked along each row. We noticed a lot of bees foraging in that area. Talked to the apple grower and found out what he had applied. Well, he did a tank combination. So he had applied carbaryl, and he was using carbaryl. They use that as a thinning agent. So the rate of carbaryl was very low, but they still had applied it, and they applied imidan. So imidan is the active ingredient in that is phosmet, and both of those are insecticides, and they do have the bee caution on them. And one of the things that was kind of intriguing there, that he had applied pyriprofoxin. So he had applied an insect growth regulator. So we started looking at that label, and the label itself does not have a lot of bee wording and bee caution on it. The only thing it said was avoid direct application and spray drift onto bee hives. Avoid application on the bee hives themselves. Did not say anything about flowering plants, vegetation, or anything of that nature. But it is an insect growth regulator. If you know how insect growth regulators work, you know that, okay, well, we start putting 2 and 2 together and thinking it's like, maybe that's what caused the issue. So the hive samples, our pollen and larvae that we had sampled, did show the presence of all the active ingredients. The flower and weed vegetation also showed the presence of that as well. So we had multiple label violations, except for the one that likely killed the larva. So the insect growth regulator, that particular brand name in that case was Esteem. So that's the one that we felt that, that's what caused the issue. We did not notice a lot of dead bees, adult bees there in the area. It was just, it really flushed out all the larvae, all the pupa, all the brood, and there any of the uncapped brood. And we've seen this in multiple investigations now using the same active ingredient as insect growth regulators. So that's something that we've come across, and it was not chilled brood. It was, you know, that we feel that was an insect growth regulator causing that issue. So, all right, case study number 3. As a field inspector, you know, sometimes we get a phone call and they'll say, you know, from a beekeeper, and, you know, they're all excited over it or upset, and they say, all of my dead bees, all my bees are dead. They're laying out in front of the hive, thousands of them, thousands upon thousands. So, you know, as a field inspector, we might get a little bit excited, start getting all of our sampling equipment together, getting everything ready to go, hop in our truck, go down there to the beekeeper, and the apiary inspector is there. A second, I don't know if this slide is advancing or not. There we go. Apiary inspector determined that the cause of the bee kill was starvation. So naturally, it didn't take 5 minutes for the apiary inspector to look at it, notice all the dead bees, and notice the, you know, the bee bottom sticking straight up in the air right there. So that's one to where, you know, we get a bee kill. You know, obviously the way the beekeeper explains it, you know, they normally say something that, you know, the neighbor was spraying. I saw the neighbor spraying last week. I don't know what he was spraying, but now all my bees are dead. And that could likely be from starvation issues. So we use our apiary inspectors will be able to determine that for us. So here's case study number 4. So on this particular one, this is one where we had 2 hives. And if you notice there just below on the ground, below the hive on the right, there's a lot of dead bees, but the one on the left was just fine. And, you know, it was, you know, I think the next, there we go. The next picture is zoomed in, so you can see a lot of bees were dead. In fact, it pretty well wiped out the whole colony on this one. And I had several videos, but I took them out just because of the size of them. But this is one where the bees are kind of on the back, kind of twisting, turning, some of the stuff that's been talked about over the past 2 days, you know, for pesticide related symptoms, and, you know, just wobbly, shaky. And I think this is one where we kind of coined the term of neonic breakdancing, where they're on their back and just kind of spinning around, a lot of them like that. So, but looking at it, there was only one hive that was affected like this. And what we always like to tell our staff in this situation, that the bees don't go over to the next, you know, to their neighbors over there and knock on the door and say, hey, look, there's some really good stuff over here. Go over here. So occasionally, sometimes you'll have one colony just find the wrong location to be able to forage in. So this particular one, I don't know if this is going forward or not. Okay, I'm hitting advance on the slide and it's not going.
Yeah, it seems like that might be the theme for today. I think there's a.
Yeah, I'm trying not to hit it multiple times so it doesn't jump. Yeah, there we go. I think it's playing.
There you go.
There we go. Okay, so we talked to the beekeeper themselves, found out what was used in the area. So, you know, they hadn't used anything, but we started noticing, you know, some trenching, noticing the condensation pipe coming out of their HVAC unit of their house. So you can kind of see it like this, started walking around trying to find out what the bees were foraging on, you know, the pollen, nectar. There wasn't a lot in the area. I think at that particular time they were foraging on the tulip poplars that were blooming up, you know, way up high in the trees. So, you know, we didn't feel that it was a pesticide related application from a spray. But we started noticing that this is where the bees were getting their water from. So it was, you know, by the condensation, you know, pipe coming out of the HVAC unit of the house. You can see in this picture on the left, the water is dripping down, and underneath all that mulch was a lower layer of plastic. Well, the homeowner made the comment, said, you know, a couple of days prior to that, before they started noticing the bees, that they had their house treated for termites. So they had them go through as a trenching, you know, application around. And we talked to the applicator at that particular instance, and they had used Termidor, which is fipronil. And unfortunately, in that particular case, when they went through and trenched around the house and they got over here to this plastic, that the homeowner asked them and said, can you not tear up my plastic? So all they did in this particular situation was pull out and open up the mulch, treat it right there on the plastic, and put the mulch back over it. So unfortunately, that created a bad scenario for the bees to collect the water. And it was, tainted water with fipronil in it. So the dead bees showed the presence of fipronil, and they had a label violation dealing with the trenching of Thermidor. So we had our structural counterparts come in and assist with that investigation. Okay, case number 5. So here's one where we had, and this is fairly common for us, where we get a bee kill. And this particular one was up in our Christmas tree area of the state, so way up high in the mountains. So we had a lot of growers and applicators there applying the same product. So generally it's always the same time of the year. A lot of the growers will start applying an insecticide over their trees, over their crop, wherever they're spraying it at the exact same time, and there's a lot of small growers in the area. So this particular one here, and you can kind of see it with the dead bee right there in the middle, is where the beehives were located at in the apiary. And all around the map, within a mile radius, there was a half dozen tree growers. We went and talked to each one of them, found out that 2 of them had applied the same insecticide, the exact same insecticide. However, the difference of the 2, you can see the one at the top right, they did a really good job on weed management between the rows. You can see there's really, it was a scorched earth underneath the trees. So there was not a lot for the bees to even come close to foraging on there. The bees aren't going over and foraging on Fraser fir Christmas trees. However, that grower at the bottom, you can see they're in between their rows in the field. You can see a lot of blooming crops. You can see a lot of blooming vegetation there in the area. That's where the bees were located at. So that's one where we were able to take action against the grower. The one that had the blooming ground cover, they were in violation of the label. And the label particularly, it had that common statement in there about highly toxic to bees, treatment of residue to blooming crops do not apply if the bees are likely to be blooming or foraging onto blooming crops or weeds. Okay, so case study number 6. So we had a call in from a beekeeper, and it was in and near a very large tobacco field. So tobacco is not an attractive plant, even if it's blooming to bees. That's generally what most people say. We've had a few apiary inspectors say that maybe they are, but we don't feel that it is. But we have a hive here. Started looking in and around the field, and the bees were not foraging on the flowering tobacco, but one of the products that they were using was orthene, acetate's active ingredient, and started noticing the tractor tires in between the field rows. And generally what they will do in the tobacco fields, because of the cultivation practices, there's usually not a lot of vegetation in and around the field. But unfortunately in this particular situation, right underneath, following the tractor tires was the gully of water. So you've got this ditch line of water, and that's where the bees were collecting, their waters, and that was their water source. And unfortunately, the water in that particular situation, the grower had applied orthene, acetate onto the tobacco. The samples from the hive, dead bees, they were positive for that particular active ingredient, but the target crop of tobacco only had a few flowering but not attractive to bees. Unfortunately, the label did not even discuss the prohibition of water, so we couldn't document any other drift. So that's a situation where we looked at a lot of different scenarios, and we were able to narrow it down as closely as we could be that the bees were killed by the water source, the acetate in the water. Okay. So one of the things we did in North Carolina last year, we partnered with Florida Department of Agriculture through a grant through NPSEC and EPA. So we did a couple of videos. One of them managing hive pests through pesticide usage for beekeepers. So we really started to see a lot of beekeepers finding false information out there. If you go in and you do a Google search or look on YouTube, what should I use to kill varroa mite in a hive, or what should I type of pesticide? There's a lot of bad information out there. So we tried to come up with some videos for training and educational purposes for the right stuff. What should the beekeepers be using? And those are found on our website. So these are free. They're available for use for anyone that wants to go out and play these and use them for local beekeeper associations and groups. We worked on those quite a bit. We're having those translated into Spanish and I believe French for our Canadian counterparts as well. But the first one there, for beekeepers, so it kind of shows and goes over the beekeeper's perspective and what they should be doing. It kind of goes over the label, a very generic, educational, outline of what they should be doing. And then secondly, we've got the one that's the bee kill investigation. That one is for agriculture inspectors. So that particular one kind of goes over it in a very general sense of, what the pesticide inspector should be looking at. It kind of goes over from the very basics of the hive components to where's a good place to sample to, certain things that's required for a bee kill. It goes over the toxicity, the exposure, the dosage, combination that we look for when we deal with bee kills, but those are available on our website along with our pollinator protection worksheet and our inspector that ties in with the EPA's inspector guidance. So those are available on our website of ncagr.gov/pollinators. Okay. And with that, I am, looks like I'm a couple of minutes ahead. So, and if we have any questions, I guess you can add them into the chat.
Thanks, Travis. That was awesome. That was a great overview. And I also remember when those videos came out, those are awesome. And I would definitely recommend folks that are tuning in to definitely check those out on North Carolina's website. So we are ahead of schedule just by a few minutes. I was thinking maybe before we get into the panelist discussion and the Q&A that we can take maybe a 4-minute break. Folks can come back and tune in around 1:30 p.m. Eastern Standard Time, just to stretch your legs, get a snack, and we'll be back in about 4 minutes. Okay, hey everybody, welcome back. It was a short break. Right now we're going to be moving into our panel discussion segment for today. So we have a few familiar faces from our presentations yesterday and today, but I am going to ask if each of our panelists could come off mute and provide a brief introduction, including, job title, your agency, just a little bit about your role. And I'm going to start with Kim, actually.
All right, let's try this sound again. How's that?
Perfect.
Yay. All right, second time's a charm. Hello again, everybody. My name is Kim Skyrm. I'm the Chief Apiary Inspector for the Massachusetts Department of Agricultural Resources, and I'm also the East Director and past President for the Apiary Inspectors of America. I've been doing this position for about 8 years, and it's just been a learning curve, and have really enjoyed it and loved it, and have a research background and trained as a research scientist, so it's really informed what we do here in our program and definitely in our department. So happy to be here. Thanks for having me.
Thanks, Kim. Now we'll move on to Jennifer.
Hi, my name is Jennifer Tsuruda. I'm the apiculture specialist for Tennessee, and I'm an assistant professor in the Department of Entomology and Plant Pathology at the University of Tennessee in Knoxville. I run the Master Beekeeping Program for Tennessee, and I'm currently the chair of the Heartland Apicultural Society. And I'm on the board for the Field Watch, which used to be Drift Watch group. Thanks.
Thanks, Jennifer. Elina?
Hi, everyone. My name is Elina Nino. I'm an extension specialist at the University of California. I'm stationed in Davis, and I work closely with the beekeepers in the entire state of California. We also do trainings for not just beekeepers, but pesticide applicators, as well as growers. We also work closely with apiary inspectors. So I've been here for about 10 years, and as Kim said, it's been a steep learning curve. So I'm glad to be here. Thank you.
Thanks, Elina. David?
Yes, I'm David Bryson, and I'm with WSDA, Washington State Department of Agriculture. We're in pesticide compliance. I'm a senior investigator. Been here almost 12 years now. Thank you.
Thanks, David. I know we also just heard from you too. You did a full introduction. Meghan?
Hi, I'm Meghan Milbrath. I'm from Michigan State University. I'm half extension, half research. I'm an assistant professor in the Department of Entomology.
Thank you. Yeah, so we got a lineup of experts here. So how this panel is going to work is that I'll be posing a question to the group that our folks here at EPA have identified, would be relevant to state pesticide inspectors. And then each of the panelists will have the opportunity to provide their response from their perspective. So I just wanted to start with the first question that we have. How frequently do you encounter pesticide issues when visiting hives? And what types of pesticides are you encountering, suspecting to be causing these issues? This is a two-part question. Whoever, wants to jump in first, we can even go in order. Kim, if you wanted to start.
Sure. Yeah, I guess I can start us off. So we're doing a little over 6,000 to 7,000 inspections a year, reaching about 600 to 800 beekeepers. So we're doing a lot of inspections, and we're seeing, as I kind of put some numbers up there in the presentation, we're getting about 20 or so calls a year, and of those, a handful, 2 or 3, less than 4 or 5 are actually due to pesticides. And in most cases, it's a lot of stuff that when we do see something that has been applied, that when an active is involved, we get a hit in some of the samples. It's a lot of stuff that's applied and homeowners are associated with homeowners are managing, urban, suburban areas, neighborhoods. I would say the chemical that's probably the most kind of head scratching, not sure how this comes in contact with bees, but is something that keeps coming up in our analysis is fipronil. We see those products, that particular active, quite a bit when it comes to a really quick and acute kill is the fipronil product group. So something that we've really had on our radar the last couple of years.
Thanks, Kim. Jennifer, Elina?
I can go first, if that's okay. I don't, so we get phone calls, or I guess I should say I get phone calls and emails, not quite as often, but I definitely get some phone calls from beekeepers who are in panic and they feel like their bees might have been killed by potential pesticide misuse. Probably I would say 3 to 5 times a year. So not quite as often, but one of the reasons probably being is that we have apiary inspectors and the ag commissioners within each of the counties. So they know that if they have their hives registered, which is now the law in California, they will contact their ag commissioners and they will work with them to resolve any potential issues, collect samples, and see what happened in the hives. In the past, some of the potential pesticide kills that I have responded to, we found some insect growth regulators that looked like they were present in there, and they have affected the developing brood. And those usually actually were not coming from the crop that the bees were on, but from neighboring crops.
Oh, interesting.
I'll
Thanks, Elina.
just add, I have a similar position to Elina. So we work on the extension side, so we aren't doing those investigations or doing inspections, since we do have regulatory folks who handle that. And in our state, we try to make it really clear to beekeepers who they need to contact for what type of service, because there is a line between regulation and education, and we try to stay in our own lanes, but cooperate really well. So from that sense, though, we still get some of these calls because we have so many beekeepers who don't know who to contact. And so we get probably about the same as Elina, maybe just a handful each year, and making sure we refer them to the right agency in terms of who to contact. And we have our pesticide division at our Department of Agriculture. But we do also, in addition to doing education, we do research projects as well. And so I currently have a student working on looking at pollen samples across the entire year in different types of landscapes, agricultural and urban, so we can assess what types of pesticides and what type of nutritional value is coming into the colony at any given time of the year. So results will be coming soon, we hope. Thanks.
This is David. Yeah, as far as number of calls we receive, it's fairly minimal most years. Periodically, we'll have something on the west side of Washington where it's rainier and more cloud cover and all. And the maple may put out some nectar for the year and get the colony started. And this would be for hobbyists mainly, and gets the colonies going really well. And then there's a dearth of nectar, and nothing happens until blackberry blossom at that point. And what takes place is a lot of times we get starvation, unfortunately. As far as agricultural calls, we only get 2 or 3 a year, and very seldom do we have hive kill problems in those conditions. I'm not sure if everybody out there in agriculture actually reports the kills that they receive due to contract type, relationships with growers, et cetera. So that's about what we receive anyway.
And for me in Michigan, I think similar to the other extension people, I wouldn't be the logical person to call just because it goes through our Department of Ag. But we do partner with the Department of Ag to do training. So they've switched. So in Michigan, we don't have a registration. We don't have a formal inspection system where you have to have your hives inspected. And so they can report a bee kill. But as David just mentioned, in our communication with beekeepers, that we feel that they're very heavily underreported, just because there's no compensation for beekeepers, nothing really ever comes of it. So it's an extra meeting for them that won't really end up in something positive. Plus, as David mentioned, there's dynamics and relationships with growers that they don't necessarily want to do. So we've gone out on some to help with to training the inspectors as they come through, but that is only maybe a small part of my position.
Yeah, definitely. That makes sense as extension folks. Thank you. So our second question is asking, what are the biggest misconceptions that you encounter about pesticides in your interactions with beekeepers?
Should we continue going in our order-ish again, or does somebody else want to jump in?
Yeah, we can keep going in the order. I think that should work.
Awesome. Well, all right, I'll lead us off. I think for us, I kind of mentioned it in my presentation. Again, if you got through the sound part of that, we have a lot of, I think for the most part, in a lot of cases, pesticides tend to be the default for when people see issues with their colony, especially if it's something that they're a new beekeeper, or they're doing different types of beekeeping that may sort of lead them to assume that that's what's happening first. Right? I think it's human nature. It's hard to assume that if you're managing bees that you could be causing harm in any way, right? Most people that have bee colonies really care about them and don't want to think in that way. But managing bees is really hard. It's really difficult. It's complex. It's not easy. And so I think if there's any health issues, we tend to see pesticide interactions being that first thing that people assume as soon as they see a problem in their colony, especially if it has anything to do with bees with their tongues extended in the colony, protruding, or if they're dead bees, on the ground. And I think the other piece to this too is that people who apply pesticides don't always have the proper credentials, or they're not following the proper procedure. So there's a big misconception around what it looks like, to be honest, even to get an application or an applicator's license to apply pesticides. I think a lot of beekeepers, the process to that is completely unknown to them. They don't they don't have a concept of how it works, or how the educational components work, or the exams, or the training. There's sort of no concept of that. So I think there's a lot of a view in this that people that apply pesticides, even if it's for a living and they have an actual applicator's license, that doesn't mean they're going to be following the rules. And of course, that's not the case, right? In most cases, these are very much set up to be professional positions, and people do get these things legally, and they do it in the correct way that is legal. But I think the misconception there is that it's not being followed. So that's from our perspective here and what we see.
I'll just add on to what Kim so nicely put into words here. Is also that there's, from my side of it, I'm dealing more with beekeepers than bee kill investigations themselves, but and it kind of relates to what David was saying, is how beekeepers themselves use pesticides is also part of this bigger picture in terms of what's actually going on, and whether or not it's not directly those miticides that beekeepers are using, but whether or not they were effectively used, and if beekeepers are following the labels and the rules and using registered products. And I think we have to be just as responsible with our use of pesticides if we want other stakeholder groups to also use pesticides responsibly. And it's this mindset too of just doing a treatment and assuming things work, and not monitoring ahead of time and afterwards to see whether or not treatments were effective, and whether or not another application might be necessary later on. And knowing how to appropriately use pesticides, the timing, the environmental conditions, as Kim mentioned, it's very complicated, and it's not like you can just open the catalog and buy anything at any given time point and use it. And also this idea that there are softer chemicals and harder chemicals, and that the softer ones will be safer to use on bees. But without monitoring and knowing whether or not the treatment was actually effective, it doesn't, the impact of the treatment, if it was ineffective, it's not truly safer for the bees if it didn't work in terms of controlling mites and keeping those colonies healthy.
I think I'm next. I'm just going to go ahead and follow up and really concur with what Kim and Jennifer have said. And I think it's so easy for beekeepers often, especially if they are, I think, newer beekeepers and they haven't been doing beekeeping for a while. they tend to sort of immediately run to the solution of it being a pesticide kill. I'm doing everything I can to keep my bees alive. It must be a pesticide kill. And one other thing that I've noticed is that maybe not a misconception, but rather misinformation and not awareness of the fact that beekeepers, when they do say, oh, it's a pesticide kill, they tend to go and say that it's the agricultural sprays that are a problem. And they totally do not see and understand that their neighbors and they themselves might be using pesticides inappropriately too. So there's that piece of education that needs to happen for us, at least, is that they themselves should be aware of what they're using in their own backyards or their bees are. So that is one of the things that we're trying to work on together with UCIPM here at UC system. And but again, yeah, it's the misconception and sort of an easy, I don't want to say easy, but it makes them feel better about themselves, is that, oh, something else happened to my bees, it wasn't me. So we do try to educate on how to properly manage the bees as well, and just make the beekeepers aware that what they're doing in the hives also matters. So I think it's very similar to what we already heard from Kim and Jennifer.
Yeah, I'll have to agree with all that, and pretty much covers it. As far as some of the problems we see with hobbyists would be marginal areas, trying to keep bees in marginal areas that do not have food sources available for a good portion of the year. No food available, and not being able to feed the bees too, or not knowing how to feed them properly. And also with that, with the stress caused there, the mites tend to do really well in those environments. And then as far as the beekeeper side, as far as commercial goes, a little bit more reliance upon artificial feeds and not putting honey back into, saving honey for over winter and things like that, putting extra frames back into hives rather than relying upon sugar. I think that does affect it some, but that's more my opinion on that. Thanks.
I love being at the end because I agree with everything that everybody else said. So that makes it pretty easy. I think maybe the only other misconceptions that I would add on top of that is people will call and they think that, that there's some sort of solution where they could get payment or they could get help if all of their colonies have received a lot of damage. And at least in Michigan, maybe there could be an investigation, but there really doesn't end up with being any sort of answers in most cases for them. And I think also we've had to do a lot of education on how hard it is to actually find the source, especially in areas where we are, where there's just so much use because there's so much diverse egg. And so unless it's hard and expensive to do screening for lots of things, and some of them break down very quickly. And if samples aren't taken, that they may do something to initiate a pesticide kill investigation, but we try to help them set their expectations for both answers and positive outcomes to be very low.
Awesome. Thank you all. Yeah, it's interesting to hear from all your different perspectives of where you work. And also just to kind of go off of the theme, about interactions with beekeepers. So how do you navigate communications and manage, maybe an emotional or confrontational interaction with beekeepers? What would your advice be?
This is such a hard question because, the thing that we negate, and I think in the world of beekeeping, and definitely we're seeing a lot more of it in science, and for sure in our world as regulators and government officials, is there's a human aspect to our job that's critical. I mean, people are like, oh, your job's so cool, you get to work with bees all day. My job is so cool because I get to work with people that love bees and that want to work with them as much as I do. And so the job really is about people. And I think if any person in our world would probably tell you the same. Like we do work with bees, we do want bees to be healthy, but if you can't work with people, if you have a hard time with these sort of interactions, if this is, you're not a quote people person, whatever that means, this is a hard place to be because these cases can get really emotional. They can get really heated. They can, they can get a lot more involved than just other areas of government work, I think, and definitely just in general working with the public. So I think the first thing to be mindful of is that when you're talking with someone that's had any sort of bee health issue, right, they probably care about their bees, because most people that keep bees, all of them, I would go as far as to say, probably keep them because they care. So there's already a sort of high emotions there, and for some people, they're even more involved in their bees. They've named the queen. Their kids have painted the hive boxes. There's a lot more, could be a lot more emotional attachment there, and so you have to be aware that in a lot of ways their pet, their family member, their loved one has experienced a significant health issue, and so you have to kind of reframe the way you go into these cases with that sort of mindset if those conditions apply. And I think for us, we try to do a really good job here of reassuring people that we're here to provide support, that we really want to try to figure out what happened, and whatever happens in these cases, that we do care, because we do. And our goal and the way that we work them here is all through data-driven means. Everything we do is about collecting data, interpreting the data, using that data to figure out, if we can, what happened, and then taking that information that we've collected, the data, the results, the pictures, the whole case, and breaking that down so the beekeeper or the complainant can understand what went on, and what may have caused this situation to occur. And, like I mentioned earlier, sometimes you just don't know. And that's the hardest part of the job. I think we are looked to as the authority in these cases, and that's great, and we should be, but we also don't always have all the answers. And I think that it can get really hard in these cases, especially if they start off really tense. If there's already a situation where there could be some, antagonistic energy there for whatever reason, neighbor to neighbor, applicator to beekeeper, whatever, there could be some real high tensions before you even show up in your car, before you even make the phone call, So I think for us, it's really about centering the beekeeper, centering the data, what actually is something that you can collect there, and being an objective fact finder. That's our goal here. We want to go into it. We want to collect as much information as we can. We want to break that down again, interpret it, and we want to help beekeepers, or whoever's filing the complaint or the report, to understand what we saw, what we were able to glean from the case, and leave them hopefully with some conclusion to the situation, but also some management recommendations. And right, oftentimes there may not be much to manage except how to clean up the situation. What do you do with the equipment? What do you do moving forward? But just really that support has to be the vein through all of these. That's the way that we work them here, very much centered on the beekeeper and providing support through that process.
Wow, that was a great answer, Kim. I don't know how much more I can add other than, since I'm extension and not regulatory, my job is a bit different in the sense that I'm not there to do the investigation, but it is one of those things of making sure that the beekeeper knows that they're heard and that they're seen, and that you're there to help them, and that you truly care about their bees, maybe not as much as they do, but also you care about their bees and their success as a beekeeper, and that you are invested in them as a stakeholder. And so even if it is a bad situation where there's not much you can do to salvage the current colony, you can still provide assistance for the future in terms of how to possibly mitigate these issues in the future, and provide other management support as well, and keeping good records, and just how to improve operation and management beyond this one type of incident, which can be really hard. But again, it's so much of it is communication, and it's not just with one person, or between two people, essentially the beekeeper and someone else. There is a whole network that's involved with pesticide bee kills, and so making sure that they know those resources is really important. That's one of the things in the master beekeeping class. That's usually like the second slide we show them, is a chart of who to go to for what type of assistance, so that they know exactly who to contact, and that they do have a short window of opportunity to get pesticide investigations done, and that we are here to work together. But yeah, it is a lot of it is just making sure that they know that they're important, and that their bees are important as well. It's a hard thing, I think, too, is everyone just says you can't make everyone happy, and so there will be some people who are very emotionally upset about the situation, and it's hard to satisfy everyone. I'll just leave it at that.
I don't even know if I need to follow up on any of this because Kim and Jennifer have pretty much said it all. One thing, again, as Jennifer pointed out, we are not regulatory, so we're extension, we provide education. And I do think that the beekeepers sort of appreciate that. And I've not personally had many or really any heated conversations other than about something that has happened, and it wasn't necessarily, as I said, due to my fault or my involvement. So it's easy for me to really, as Kim and Jennifer pointed out, sit there and listen to them. And I feel that's a lot of the times what the beekeepers do need is somebody to hear them out and provide any potential suggestions and recommendations for how to move forward. And one thing that I did learn, and as an educator and extension specialist, not necessarily a regulator, is not to tell anybody what to do, but to provide guidelines and suggest what they might do in the future, and not say you need to do this, but really just say, hey, have you thought about this? What about this? Were you aware of that? So that is really a big thing, I think, and they really appreciate that because a lot of the different beekeepers have different situations, right? They have different goals within their beekeeping operations. So I think they really appreciate that. And as I said, just somebody to hear them out and see if we have any suggestions for them for the future seems to work really well for everybody.
Yeah, from the regulatory aspect, end up in the extension side too periodically. For instance, one time a call didn't want to file a complaint, the person in it. He was actually a commercial beekeeper and had his bees a little ways away, less than an eighth of a mile. From an orchard he complained about that was spraying all the time and affecting his bees. Went out and looked at it, and basically he hadn't provided any water source. And the bees were going over to the orchard and using the leakage off the drip and sprinkler irrigation system. And so that was able to actually work that out and get him to put some water into the area and try to tell him basically you should have moved the bees at that point because they were trained to go over to that water source, but it did help out anyway. On the hobbyist side, it's a little bit more difficult. Sometimes it's hard to tell a hobbyist that you've loved your bees to death. Put too much shade over them over on the west side, perhaps, and they aren't able to warm up enough in the daytime and go out and forage and all that. It's, from that aspect, it's good to be able to tell them about the University Extension here in Washington and organizations they could contact and different references or books they could read. That'll help them out on that. Thanks.
I don't think I have anything additional to add. Great job, panel.
Thanks. Yeah, I think, there's a variety of people, obviously, that work with beekeepers for guidance, for education, from a regulatory standpoint. And I think it's really important to hear all of those perspectives. I think this panel did a great job at collecting those viewpoints. So we can kind of provide that perspective for folks. So thank you to all of you for agreeing to be on the panel. You did a great job. And now I think we're going to conclude the panel discussion segment and move into our Q&A with questions, we've collected from yesterday and today that our 5 panelists will be answering. But before I get into the questions, I just have a few housekeeping announcements for everybody that's tuning in. So as a reminder, you can download today's presentation by pressing the paper icon, which is highlighted with the green arrow. And you can also continue to submit questions while we're going through this Q&A. To help us with future webinars, we ask that you complete a brief online evaluation. At the conclusion of this webinar, you'll just wait for this box to appear. When it does, you can press the close button to be taken to the evaluation. After answering all the questions, you can press the submit button to ensure your credit for your attendance. About an hour after submitting the evaluation, you'll receive an email with the link, which is circled here in red, to access your certificate of completion. So this is what the certificate is going to look like. Okay, so now we can get into the Q&A for our presenters. And basically, I'm just going to, pose this question to the group, and anybody that would like to provide a response or, just wanted to provide their perspective, feel free. So I'm going to start with some of the questions that we received yesterday. One of them is asking if bees that are visiting non-nectar producing flowers, will they visit non-nectar producing flowers, or can they tell before contacting the flower that there is no nectar? So this is a general question about bees.
I can take this one because I think it was probably during my talk. So bees can tell if there's nectar there both by sight and by smell. And so either if the plant is a nectar producing plant, but also if it happens to have nectar in it. So they can usually see the nectar, and then they can also will be able to smell it. They can also find large areas where bees have been foraging quite a bit because they'll be able to smell that other bees have been working the flowers in that area as well. And obviously other people can add to this too.
I guess I'll add that, there are some plants that have flowers that are, well, the male flowers that are producing pollen. So yes, they will visit those non-nectar producing flowers that are also producing pollen. And then some plants have extra floral nectaries that secrete sugary liquids that the bees will then collect from, but it's not at the flower itself.
Thanks, Megan and Jennifer. Okay, so another question we received is specific to alcohol wash. Can you alcohol wash dead bees for varroa mites, or only live ones for an accurate count?
I can take that. This is Emily Wine. You definitely can alcohol wash dead bees. However, one thing I've noticed is that if it's really been dead for a long time and the beekeeper was not prompt about reporting a bee kill, then I've found that severely decayed varroa mites fail to sink to the bottom so you can count them easily. But as long as it's not severely decayed, it should be the same process as with live bees.
Thanks, Emily. Yeah, I didn't realize you were here, but that's awesome because I think that also was from your presentation yesterday. So thank you so much for jumping on. Okay, so on the topic of varroa, is there any recommended way to prolong varroa treatment products after the expiration dates?
This is Megan. I get this question a lot, and my recommendation for this is always for them to talk to the manufacturer. Most of the varroa products, they will have somebody who is there to answer the questions, and then it doesn't put me on the hook if there is an efficacy issue. But at least like for Formic Pro and for the oxalic, there's usually a person that is able to talk to them about how products should be stored and what the expiration date means.
I'll just make a quick plug, everybody, that along with what Megan said, that's such a great resource to have, is to know where these products are produced. So if you haven't looked on the packaging for your miticide products, make sure that you have packaging that has a label on it or inside of it, so you know how to apply these legally, because the label's the law. So you know, I think you need to definitely have these folks on your back pocket of who to contact if you have questions in the manufacturer's world. But if you have questions on how to apply them or anything specific like this for your state, I don't know that anybody would ever have a problem answering questions about how to read a label or what it means on the label if there's material or documentation or language you don't understand. So just reach out to us. We'd be happy to help you interpret label language if you ever need help.
Thanks. Okay, so as a pesticide compliance investigator, is there a standard practice for addressing beekeeper off-label use of a pesticide?
This is David. Can you repeat that question one more time, please?
Yeah, absolutely. As a pesticide compliance investigator, is there a standard practice for addressing beekeeper off-label use of a pesticide?
Okay. Basically, it'd be a violation of the label, and could end up in our state as an NOC, and notice of correction, and basically that the beekeeper did not follow the label on that. So they should be, you know, the label is a law, so they should be following that, you know, to the extent of the law there.
And this is Travis. I do want to add in on that one that we have actually cited beekeepers for off-label use in North Carolina.
Thanks. Okay. So an interesting one that came in yesterday. Can bees build a tolerance to pesticides like weeds over time? Specifically, can bees become pesticide resistant?
As far as, this is David, I haven't seen that take place. Some of your researchers might be able to help with that a little bit more. But one of the biggest troubles you do see, it's a little bit off subject slightly, is that the mites will become resistant to the pesticides used against the mites in a colony on that.
I would say for follow-up, this is not my area of expertise, but I have heard Reed Johnson at The Ohio State University give a really nice talk on the detoxification pathways that bees do have. And he gave that to some veterinarians at a conference a while back. And I don't know that he went so far as to talk about resistance, but he does talk about, you know, that bees are able to at least withstand and process quite a few chemicals, including some of the pesticides. But he does a lot of that work with pesticide receptors and pesticide action at the individual bee level.
And this is Elina, just to follow up on what Megan just said. And again, we don't want to necessarily say, oh, it was development of resistance, but I do know that there's some research showing, I think this was from Joe Malone from NC State, that showing that there are some different honeybee stocks that are differentially, again, I don't know, susceptible, I guess, differentially susceptible to different pesticides. So it looks like there's some difference between the honeybee stocks. So one might say that we kind of inadvertently selected for that by selecting these different stocks. But again, we're all very, you can tell we're all very careful to say, oh, it's development of resistance, but it happens in a variety of other organisms, especially insects. So it's a possibility. It really also depends on the amount of these pesticides that the bees are exposed to as well. So probably possible, but again, we do know that Again, we have some data showing that different honeybee stocks do have different susceptibility to these pesticides. So I will definitely point you to go and maybe look at, I think it was Joe Malone who was looking at this specifically with, I think, larval honeybees.
Yeah, and I guess similarly, yeah, I'm kind of hesitant to say anything definitive on those either, but also there's been research that has shown that nutritional availability during larval development can influence the susceptibility of those same individuals when they're adults to pesticides. So I think that's kind of hitting it, that it's a really complicated thing to talk about susceptibility and resistance. And so there's a lot of factors, and it's just, biology is really complex, but nutritional aspects are important as well.
Awesome. Thanks, everybody. Okay, another question. So would artificial heating of the hives both early and late in the season be advisable to prevent cooling deaths, especially for young bees? And may it also help to prevent starvation in many cases? This was a question from yesterday. I'm not sure if anybody wanted to comment on it, but
I mean, I'm happy to comment on, I think the one point is that artificial heating, like if you want to talk about practices that are actually useful to beekeepers, there's always a cost benefit calculation. And I do know beekeepers who have tried using heating elements, and I've never heard of anyone who had one that actually was, by the time you put in the element and you put in the heating and things like that, that it's actually like made it through a cost benefit analysis, especially when you talk about scale. And then heating up too doesn't necessarily reduce heat things. I think what this person maybe would be interested in though is there are a lot of research right now happening on indoor storage and controlled temperature facilities, and those it's becoming very popular among the beekeepers that I work with, and a lot of people are interested in. And then Project Apis M did a really nice webinar and has a nice handout on that. And they are used in Canada quite a bit, and in the West, where people are keeping bees at more controlled temperatures, either in the summer or to induce brood breaks or things like that, but not necessarily heating. In most of those cases, they're cooling them down. So I know hobbyists have experimented with heating, but I don't think it's something that really is useful. And also you get into issues where they're still going to be out in the environment anyway, and having them, build up in a way that is useful in response to the local environmental conditions is usually what's going to be the thing that's going to be best for them.
thanks, Megan. Okay. As an inspector, do you wait for sample results to confirm the cause before continuing your investigation, or do you conduct your investigation while waiting for sample results?
This is David. Yeah, as far as the analysis go, in most cases, unless it's something that's very, very obvious like starvation, we'd wait for the analysis. In most cases of starvation, we wouldn't even sample though. As far as continuing the investigation, there are certain parts of the investigation that might be needed to be done. As far as gaining records from various growers around the area, and that could take quite a bit of time, as we saw, as how far out you actually have to go to obtain those records at times. So we continue the investigation while waiting for the analysis, and then the analysis will play a big part of the investigation. Thanks.
Thanks, David. So I think this was a question from today too. Is there concern with commercial hives transmitting diseases to non-commercial hives?
Hannah, can you please just repeat that once again?
Oh yeah, absolutely. Can everybody hear me okay? So the question was, is there concern with commercial hives transmitting diseases to non-commercial hives?
I will, I guess, start the discussion on this. I think that there is a risk in both directions, as it is with everything. So it would be really unfair to say, oh, it's the commercial hives or non-commercial hives. I really think it just depends on sort of the management of the individual beekeeper, and what they're doing to manage a variety of different pests and pathogens that we know exist within the colony. So I would say there is a risk of transmission regardless of what the, I guess, hive belongs to, right? So it's not necessarily the commercial versus non-commercial. It really is the management that should be taken into consideration. It really varies from beekeeper to beekeeper. So again, as I said, it's bi-directional, I would say, and oftentimes it really depends on the level of knowledge and understanding of what's going on in the hive, and even knowing if you have anything that could be considered a problem for not just your own hive, but the hives that are surrounding you as well, and being able to mitigate that issue. So I think that is probably fair to say, and I'd love to hear what others on the panel would say.
I'll agree with you, Elina, that yeah, that's definitely going both ways depending on the individual beekeeper. But I think something that has been brought up, but something to remember, is that when moving bees across state lines, they're to be inspected, and there are exit permits and entry permits, and so that's involved with commercial beekeepers. And depending on the state, there are different rules and policies about moving bees even within the state. And whether or not they need to be inspected at some level for that as well. And then, as Elina mentioned too, there is a difference in terms of the level of experience that can be at play too, or that can be a cofactor in some of this too. But there's definitely possibilities to transmit both ways. But that's why, thank goodness, we have inspectors that can go out and do these inspections and allow write-up permits. So thank you, inspectors.
Just wanted to see if anybody else wanted to comment before I move on to the next question. Okay. All right, so this, I think, is a question from yesterday. Can fungicides cause a direct bee kill at a colony?
I'll go ahead and, this is Dave, I'll go ahead and comment on that. I don't know for sure if we have any proof. I mean, if you sprayed it directly on them, of course it would, possibly. Some of the main concerns with the fungicides are actually the surfactants that are put into the tank mix with those. And they could be pretty hard on the bees themselves, and actually affect how the fungicide affects the bees too. But as far as there's still a lot of data that's needed on that, more research being done. Some of the research is showing that two fungicides together, and some of the researchers could comment on this more, can actually be a larger effect on the bees. But as far as a direct kill, not sure on that.
We did a review a few years ago about fungicide effects of bees that are published, and I think the last point about more research is needed is very true. But we made this huge table, and that was kind of what I was alluding to in my talk about sometimes, you know, where it's maybe more uncommon to see these direct bee like we don't see these acute bee kills with the piles of dead bees that often. That is a rare event. What is very, 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 very common is that beekeepers have these colonies that are dwindling. And when you measure, so at least where we measure pesticides that are in incoming pollen or in wax, by far both the greatest amount and the greatest number are going to be fungicides. And there is a whole list of published subacute or sublethal effects from them. So it is very likely when you have high levels of these things that cause all these sublethal effects that they can disrupt the balance of a colony and lead to other issues, especially as someone mentioned, in cases where there's poor nutrition or other stressors at play. So they maybe don't lead to these acute losses of adult bees, but especially when, and then also as mentioned, both mixed with other fungicides and then also mixed with insect growth regulators, they can have much worse or potentiating effects as well.
Awesome. Thank you. Okay, let's see. So another question from yesterday about, bee biology, bee health, and development. Do winter bees get different food during development to allow for their longer life?
This was from my talk too. I just feel like I'm talking all the time, so I was trying to be polite. I don't know that there's evidence that they get different food, and one of the things that triggers them kind of coming in is the reduction of incoming pollen. I think where the biggest difference is that they are not responsible for using all of their energy at the beginning of their life. So a summer worker bee is going to draw from their body a lot when they produce all of the royal jelly. So they'll be pulling a lot of fats and lipids and producing a lot of that. Whereas because the winter bees don't have to do that nursing at the beginning of their life, they're able to retain a lot of that energy within their bodies. Other people can add too.
I think you answered it really well, Megan. I don't really have much to add on that. I think that's exactly it, is that they aren't losing it, they're keeping it within their bodies. And you can measure it by looking at like fat body levels and physiology. But the question too is in terms of when winter bees get made and in different regions is up for question as well.
Thanks. Yeah, thanks to you both. And Megan, you're doing a great job. Don't hesitate to, to unmute and answer these questions. So, okay, a question from today. Is there a lab that we can send freshly sprayed foliage to be tested to see if what they are spraying is fatal to bees? So, for example, a utility company sprayed right away.
I can take this one. So for our pesticide lab here at the state, we obviously use the state lab. There could be something at the state level or even a nearby state level that will allow you to process vegetation samples. I think, for instance, right, our lab here will process vegetation samples. So a lot of labs that will do pesticide analysis as a whole, the comprehensive screen in whatever fashion, they'll typically process a lot of different types of samples. And typically, to be honest, bees are usually kind of outside of their wheelhouse. So we usually have to kind of bring labs up to speed when we work with them on bees. And so plants and soil, substrate, all that stuff is kind of already in their world. But yeah, we have very good luck with our state lab. Now on a national level, I think you can use the USDA AMS lab down in Gastonia, North Carolina. I think they will also process vegetation samples. I'm not sure what that looks like. You'd have to contact them to get information about fees and turnaround and materials and packaging and shipment. But there could be that option as well at the federal level, and perhaps even Cornell may be processing vegetation samples. So I would reach out to their lab as well to check in, because I know they've recently come into the world of pesticide processing and are making a big hit with a lot of people doing a great job of working with bee samples. So they might also do other types of samples. And I can't, again, stress enough about how important it is to take all sorts of samples. I really focused on bee samples, but I think in general, right, if you have a pesticide applicator or investigator involved in these cases, they will have a much broader knowledge and understand how to take other types of samples, swabbing the hives. And actually, Travis, you did a great job with that, kind of showing people how to look at this from the pesticide inspector viewpoint, because there's a whole nother world to this. If you're doing these cases just from an apiary inspector view, you're missing a big part of this, and these folks bring expertise to it. So, definitely look into taking other types of samples as well.
Awesome. Thank you both. Okay, so when you have positive detections of an active ingredient in bees, how far out are you looking for sources of that active ingredient? Are there examples, where you are unable to find or determine a responsible party who was applying the active ingredient?
This is David. It's going to depend on the situation, time of the year, what's available in the local area, and if you could determine what would be attractive to the bees in the area too. You might have to go even out as far as 4 miles, but it just depends. Past half mile out may not be feasible at times, and there just may be too many different things going on. But it's good to get records at least. You don't need to do the sampling per se, depending on the type of investigation you're doing, but at least get records out a ways to see what's going on in the area, see if anything matches up.
This is probably the hardest part, to be honest, of these investigations, especially if you go into it with no information. The beekeeper, no one involved has no knowledge of anything that may have been applied, even in the landscape, if it's already kind of a question mark. If before you show up, instead of like, oh, I saw this company or that truck or that little flag on the side of the road, signpost or whatever, it's difficult. And I think this is why these cases can get really daunting and complex. And to be honest, a lot of states and territories and areas that do these investigations don't have the resources nor the ability to you can't look at every plant in the environment, and so I think what you mentioned, David, is a great way to think about it. Where are the bees, where would they be active right now? And I know someone mentioned it earlier, and I'll just reiterate, you also have to be mindful, right, of other places they're going to go that you may not be thinking of them going. And I'll give you an example. We had a case a couple of years ago where someone, a grower, had applied chemicals to his crop of corn, and bees, right, shouldn't be going in a cornfield, but they do. And so there wasn't a situation of a misapplication because it was applied according to the label, and there was nothing that was off, nothing that was not legal in the application. But unfortunately, bees went to that plant and got into those chemicals, and it created a negative situation where the colony died. So sometimes you have to kind of get creative in these cases as well. And even if it's not something you think bees may go to, it may be something they are going to. So, and bird seed, bird baths, anything, right? So I know Travis did a great job kind of showing you some of these cases, and they can be a little bit more complex than just, oh, I think it's going to be pretty easy when I show up, So you got to get really creative on some of these, especially outside of the box, because as you all know, if you try to tell a bee where to go, man, I wish we had that kind of capability. We'd be in a different world. It would be much easier to investigate these, but that's not where we are. So they do what they need to do and what they want to do out there.
Yeah, kind of investigating bee kills, it's like Kim said, it can be very complex. Sometimes we're out there shooting in the dark, and occasionally sometimes we'll go into a bee kill and we can confirm that they were exposed to pesticides, what they were exposed to, but we don't know how they got into it. And, you know, sometimes it's shooting in the dark. Sometimes we start very broad and try to, you know, target our investigation into an area if we can find it.
And I'll just reiterate at the tail end of this, Travis, exactly that. One thing that's been a great tool for us here is to have that ability to take a honey sample or a pollen sample, nectar, bee bread, whatever, the resource samples, and actually have a lab, you know, analyze that, as I mentioned, and tell us at least what plants. I mean, if you have some basis there, right, you can go back and say, okay, who sprayed, you know, X, maybe we can start from that end instead of, I have no idea where they went. I know they got into chemical X, but I don't know where they got it from. And so hopefully you can start piecing this case together a little bit more. So it may not solve it for you, and hopefully it doesn't create more confusion, but you know, it's nice to have that information, at least to know where the bees may have been collecting what they were collecting. And I mentioned that you could obviously collect it on the frames, but you can get these samples too, you know, from the bees. So if you have, I know yesterday there were some great photos of bees that were returning back with pollen on their legs. So you can even take that pollen, right, if they're expired, if those bees died. That's a great another, you know, piece of information for you to collect and analyze. What were they getting into? Maybe that was part of their death, you know, their demise was visiting that plant.
Thanks. And Kim, while I have you on the line, this is specific to your presentation. So who pays for the virus, fungi, and bacteria testing? Is that the State Department of Agriculture or the beekeeper?
So here in our Department of Agriculture, we've been able to pay for the sample processing out of our own budget through the apiary program through our Department of Ag. You know, obviously beekeepers and anyone can submit samples and pay for them on their own, but we do take care of all the sample processing for our cases, especially as it relates to pesticides.
Thanks, Kim. How adaptable are bees to long distance moving, especially across state lines? And what is the effect of that on the overall health of the colony?
I'll start this one off, but I hope someone else will finish this. So there is research looking at transportation stress of honeybee colonies that are moved, but they are amazingly resilient, especially when you consider putting them in an entirely new landscape with a different climate. And well, the stress of transports is what it is, but then when they get to their destination, oftentimes not the final destination, and they get moved again, for at least we're talking about big pollination. But then they have to learn these new flower types that oftentimes they've not been exposed to in their lifetime before. So they have to learn where these food resources are, how to work those flowers. So there's a lot that's involved, but they are surprisingly resilient, but it is stressful. My classes always tell people, we can understand the stress of transportation. When you think about airports, it's usually one of the least happiest places on earth. And we know where we're going, and these poor bees have no idea where we're moving them off to. And they've never been on such a long ride before. So it is stressful, but please, someone else chime in.
Yeah, as mentioned, it is stressful, but also to put it in human terms, a lot of times they end up in a lot nicer places. So in Michigan, you know, transport is stress, but also I can tell you personally that living through Michigan winters is also stressful. And they get to go to, you know, a lot of our bees go to Florida, Georgia, and then California, which would also be my preference. But in their case, it does mean available food. It also means that the beekeepers have a longer time to manage diseases. So right now I'm having a lot of conversations with beekeepers who are managing Varroa. And if you're a stationary beekeeper and you don't have Varroa under control by right now in Michigan and they're staying in Michigan, then those bees are dead. If you're a migratory beekeeper and you're still kind of trying to get the levels down and you're going to bring them to Florida, you do have time to continue to apply treatments and to manage, and they won't be going through this period where they're going to have to live off of their fat bodies or go into this winter cluster. So, you know, there's the downside of having the transport stress, but there's the upside of ending up in a place where a lot of time you can manage disease more and there's more food available. But then also, if you never break the brood cycle, that can also lead to disease. So I would say it's not necessarily better or worse. It's definitely just trade-offs.
Thanks, Megan and Jennifer. So when doing a bee kill investigation as part of a possible enforcement action, do you routinely conduct an alcohol wash to determine Varroa load?
I sure hope people do. That's really important, everybody. I sure hope you do. It's 2:35. We're kicking this party off. Yeah, no, seriously, I really do hope people are. I mean, it's such a critical piece of information, and like I said, sometimes you get to the end of these cases and you never want to go, I wish I would have collected that, or I wish I would have did that, or why didn't I take time to do that, right? It's much better to be in the position where you go, wow, I have so much information here. How am I going to put this all together in a way that makes sense to the case, the beekeeper, the bees? So it's even if the Varroa mite wash ends up being 0, which it probably won't be, but it could be, it's better to have that data than not. And if you're on the fence of how to take it, where to take it, you don't have enough bees to take it, I mean, again, do your due diligence. And if it ends up being data that doesn't really contribute to understanding the broader case, then that's okay. I mean, there's a lot of that kind of stuff that happens sometimes in these investigations. You just kind of cast a very wide net and you hope you get some good stuff in, and at the end that makes sense for everything. But yeah, I would always encourage people to take it. It has definitely been, at least for us, it's been really important in trying to figure these out, because that's a whole other conversation, right? With the beekeeper, with everyone involved, is and we start out these screens that way. And what are how are they managing their hives? What are they using? Have they used chemicals this year? When did they use them? It's a big part of our original conversation. And so if you go there and you're not seeing signs of any sort of chemical management as part of their IPM plan, right? So now this investigation has a lot more information you can gather.
Yeah, we pretty much do the same thing. Our apiary inspectors, lots of times they will do the mite count. And I've noticed from a pesticide perspective that sometimes it's done more of an educational thing, that we go up and we talk to the beekeeper and say, when's you last do your mite count? When's the last time you did a sugar shake, alcohol wash? And they kind of look at you kind of like, what's going on? So then I kind of see it as more of a educational thing for beekeepers, maybe in the future, that they could start tracking and monitoring their mite count. And we do the same thing with pesticides. Sometimes, even if we don't think that pesticides are involved and we can pull a sample, we will go ahead and pull a sample. Sometimes just having that information and run it, sometimes just to go back to the beekeeper and say, hey, look, there was no pesticides found. So we'll use that both ways as well.
Yeah, as far as doing a mite count goes, most of the time don't have a need to, because by the time we get contacted about the kill, it's too late at that point. If it's available, as far as enough live bees to do that, we'd do a shake or alcohol on that to determine what the mite load is. But most of the time you can see the evidence right there too.
Thanks. Awesome. So, during the inspection, if there is a clear Varroa mite issue, have you found that there's reluctance to pursue pesticide residue analysis?
Again, like I said, even if we see a high mite count, we will actually pull a sample of the bees just to run them for analysis, just to see if they were exposed to pesticides. Even if we suspect that it is Varroa mite, anything like that, occasionally we'll come up to one that's, it is blatantly obvious that it's starvation, and we won't run it. But, if the beekeeper's sitting here saying, it's like, oh, I saw them spraying, we'll go ahead and pull a sample, to run it for analysis. we'll do a pollen sample. Sometimes we'll get the results back and we're like, where did that come from? Or, and we try not to sample wax because wax is reused in the hive. And, sometimes if we do sample that, we're trying to figure out where did that come from? Did that come from a previous beekeeper? Did it come from their, a nuke that it came, that originally started from, so we run into those issues as well.
Great, thanks, Travis. Okay, do you have an estimate of how long after a bee kill incident that it may not be worth investigating for pesticides, based on concern that the evidence would have likely dissipated?
When we talk to our beekeeping groups, like our county associations or state associations, and we're trying to tell them, let them know up front what we do, we always say you need to call us immediately. If you call us, 6 months after your bees have died, there's not enough for us to go back and properly investigate it. So we're always, pushing that and trying to educate the beekeepers during our outreach events and just let them know that, hey, look, if you have a bee kill, don't wait. Call us. A lot of our pesticide related incidences, investigations we do, sometimes it might be a day before we can get out there, depending on the situation, within 24 hours. Whereas a bee kill, we're looking at it, we need to be out there immediately. Go ahead and take the sample. If we can get out there and take some pictures, videos of the bees shaking, wobbling, get some samples of the bees that are actually exposed and exhibiting some of the pesticide related symptoms, we need to be there immediately after that. But, if it's 6 months, a month or two down the road, or even a week or so, sometimes it's too late. So we try our best to do during our outreach events, let the beekeepers know to call us immediately.
Yeah,
So-
totally in agreement with Travis's immediately. Anytime that takes place, that lapses, it's very difficult to get information that you need and find out what's going on. The sooner the better. If it gets out beyond a couple of weeks, it's going to be real difficult to actually ascertain what took place. There's probably multiple stressors available that you could look at, but may not be conclusive in most cases.
Yeah, I'm not regulatory, but I'll just add, I believe our Department of Ag wants to do investigations within 2 to 3 days because there are some chemicals that break down rather quickly. Some can persist longer, but some can break down really quickly. And then the concern is if investigation or doing pesticide analysis is done beyond that point, you will get results, but whether or not you can interpret them correctly is a big concern. And so as Kim has mentioned multiple times, we really want to have data that we can rely on. And so having some possibilities of collecting samples and doing those analyses later on when they will not reflect what was happening at the moment, that can actually mislead us sometimes. So we want to make sure that the conclusions we make are solid.
And I totally agree. I think this is so important to get out there fast. And we always joke here and sometimes it happens, but not often, but our kind of running joke is that bee kills only happen at Friday at 5 p.m. because, right, people usually take off Fridays when it's good weather. And so, it's really hard sometimes to get there. Here we try to do 48 hours as our window, and again, if it happens on Friday late afternoon or something like that, it may be really hard to mobilize the team. So I would encourage everyone to come up with your best plan on how you're going to handle these if you don't have that already, and then kind of that backup plan, like what's going to happen if someone's on vacation, or if something does come in after hours, or if somebody happens to find see a request on a weekend. Like, is there kind of a quote unquote B pun, a B team that'll get out there, or a B plan that you can have that's not your A plan or your A team that can help this process? And for us, we have a very strict chain of custody process that we follow here. So, if there are ways that you can help you and your team, best support real-time response to these cases, but also maintain your SOPs, maintain, whatever is required for your chain of custody, I just would behoove, it would behoove you to think outside of the box if you need to get to these cases quick. Because after a certain point, right, we've had so much rain, for instance, this year, it just is, how do you interpret anything, right? And of course, rain is not always easy to deal with in these cases. So weather is not an easy thing to manage around. So just make sure you come up with a plan B in these. That's my tip there.
Thanks, everyone. That was a great discussion. So we have a question asking, have there been any instances of pass-through larvicides affecting honeybees? And it looks like the person that asked this question, they might mean mosquito pesticides. I'm not entirely sure. But yes, asking, have there been any instances of pass-through larvicides affecting honeybees?
I don't want to speak for everyone here, but you know, it's hard to say never on any of these chemicals because there's a lot of conditions that could be kind of create a perfect cocktail for anything to become an impact on bees, especially chemically related and the environmental, whatever you've got happening out there, and environmental conditions. So, you know, is it a common theme that we've seen in our investigations and or results? No, but could it cause an impact on bees? For sure, right? I mean, these chemicals, if they're an insecticide, they're designed to kill insects, right? They're a pesticide, right? They're designed to kill pests. And so if you're in that insect group, if you're applying something that is targeted for those organisms, bees are insects. So there can be a lot of instances where things can happen that are completely unintended and are applied in a safe and consistent manner with the label legally. So this is a hard question because it's a never say never, but also it's hard. I mean, there's so many different products being applied in different ways, and obviously so many different environmental conditions and geographic regions in this group and within our world that we have bees in. So it's a difficult situation, I think, to say yes or no. But you know, we've not seen that as a theme here in our investigations. No.
I'm just going to follow up on what Kim said, and I'm not regulatory, as we all know by now, and I haven't had any complaints by the beekeepers yet. Nobody has reported anything, and I think that is the point. Again, never say never, but we've had pretty heavy mosquito sprays going on in the area where I am more recently due to West Nile outbreaks, I believe, and I have not heard of any beekeepers saying that they had at least seemingly related colony losses after those times when the mosquito sprays happened. So again, that doesn't mean that it couldn't affect them, but so far from what I've experienced, it has not been reported due to mosquito sprays. So,
you know, and I'll just follow up here. If you know, folks are on here, they're not sure what to investigate or not, or how to sort of screen these calls. I mean, there is somewhat of an art to this, and in a way that kind of reading, right? As an inspector, a lot of our training is again people, but also kind of reading through what language is being shared and in a lot of ways. And again, I want to just stress that, and we're doing these screening and calls, that you consider that as part of this, because a lot of folks are very quick to make assumptions and connections to things that may not be there. And so you really need to use data, that objective fact finder lens and hat through this whole investigation process if you get these calls. And also on the flip side, take every call seriously. You know, we treat them all as if they are a bee kill, and then we work from there. You know, we don't treat them as if there's nothing happening and, oh, you have to convince me. We actually do the opposite here. We treat them all with the same severity and attention to detail and seriousness that they deserve. And then at that point, we get data to help us figure out what's exactly happening. So I would just encourage people, you know, don't assume that you know what's going on there as you're talking to folks, but you also have to do some real sleuthing, you know, in your communication with people and ask good questions, because folks are in these cases tend to be, in our experience, really vocal and very candid about what may or may not have happened. And it's, you know, they may even have documentation for you as well. They may have videos, photos. You know, I saw someone do this. Here's the truck. Here's the video. Here's a photo, you know, whatever. So you got to get a little bit more creative in this and read a little bit in this conversation to ask good questions, because if there are impacts like this, you know, the assumptions are not going to help out. Go into it just looking for data. Give me all the data you have, and let's talk about where we move from here.
Great, thank you. So I think for, you know, just the last question, because this audience is, this webinar was intended for state pesticide inspectors, that I wanted to hear from maybe all the panelists today, you know, what is the single best advice that you would give an inspector that's dealing with a bee kill and or dealing with a beekeeper? I know we talked about in the panel a little bit about, you know, navigating communications with a beekeeper, but what would be the single best advice they would give an inspector dealing with a bee kill?
I'd say the advice that I would give is really the same kind of advice I give for all investigations: is don't assume. There's so many variables out there, like Kim had said, that, you know, me as a beekeeper myself, I know when I've had multiple hives out in the, you know, in my apiary, that they all behave differently, every one of them. So you can't go out there and assume anything. You know, sometimes you can go out there and, you know, kind of shrug your shoulders and think it's like, oh, this is definitely this. This is definitely a hive. It could be this or that. Whereas come to find out that it may be, you know, a beekeeper, you know, self-inflicted, where they applied, you know, off-label products inside the hive. It could be something nearby. You know, it could be a combination of things. You know, we've had a case before to where we had a beekeeper in a large urban area, and, you know, had lots of bee kills, and we started looking around, and we felt that it was a, you know, someone with a nearby pool that was upset with having bees coming in and, you know, all around their pool all the time. So we feel that that was a, you know, intentional bee kill. So my advice to any bee inspector or pesticide inspector working a bee kill is never assume anything.
And I think that the last statement that Kim said was probably the best, or what I would echo, of just kind of, which is also just echoed there, of not assuming things, but giving everything all of the respect and attention that it deserves. You know, we have a lot of people that you could assume that it's a pesticide kill, or you could assume that it's the beekeepers, but in reality, just not knowing. So making sure that it does get the respect and attention, and also just keeping in mind that, you know, these are in a lot of cases people's livelihood and their livestock. And, you know, how would we treat it if 200 of someone's cattle went dead from poisoning is very different. And so a lot of times people don't necessarily give bees the same respect that they do for other food producing animals. But when you're dealing with deaths of large amounts of food producing animals, even if it is an issue where the beekeeper management was at stake, that's still a very serious and, you know, potentially devastating incident.
Yeah, I'd say that's all right. And never assume is very accurate, and also ask lots of questions. A lot of times they'll forget a little piece of information that might be really important. You found out later that it links up to something that you hadn't expected maybe.
I think the bit of advice I would give here, you know, is that if you're doing an investigation, it's really important to be candid and clear. You know, we try to give folks an idea what to expect, right? This is how this is going to work overall. This is the step we're at. This is the next step. You know, this is kind of a timeline on when we think things may happen. And when you do that, be clear about what you can and can't share, and hopefully have a conversation about expectations. You know, is this person going to go on vacation? Like, is there gonna be someone here if you need to come back next week to take another sample? Is there a better way to contact this person if they, you know, if they need to do a management question? I think just kind of giving people a really good view as much as you can of how the process works, because right, a lot of government is unknown, and I think when we have a lot of unknown, we create a lot of room for people to make assumptions, and we don't want that. We want folks to be confident in the government. We want people to understand that we really do care, that we are here as a steward of support for you, and we really are trying to figure out what's going on. So as the best of your ability, I would urge people really try to give a good, clear overview of how this works, what your role is, what their role is, if anyone else is involved in this, who they are, you know, what they're going to be doing or not, and kind of what to expect, because that'll really help you as well. You know, people get really excited to know results of these, and they want to know, both from making a management decision, right, and just also want to know. I mean, they've reached out, they care enough to contact and start this. So I think that's been a really good thing for us to learn here, is how to understand sort of how to navigate this from the perspective of understanding where people are coming from and being as transparent as we can. And the flip side of that, right, as a government steward, we're also proxy to personal information and documents of investigation. So, you know, don't get really excited and start sharing things about this process until you get done with your case. I mean, I think it's, you know, however your state handles these, that's probably under a very different proxy. But, you know, in general, I think it's really, my best advice is to be clear about the process, but also be very clear on what your findings were when you have all of your information and have made those conclusional findings to the case. Don't share every little nugget along the way unless you're ready to deal with the questions about every little nugget, and or you're ready to handle if that does not, those pieces don't add up for the beekeeper or the complainant the way they added up for you, right? So you got to be aware that there could be some difference in how this is being put together. So I would really behoove you to think about the end of this. And of course, again, be transparent. I mean, if it's going to take the lab a month, don't say, oh, we'll get you some results, you know, samples back in a couple of days. Like, be straight up with people. It really causes a lot of confusion and, quite frankly, a lot of frustration if you're like, oh yeah, we'll get you some samples soon. What does that mean? You know, if you don't know the date of it, that's fine. We don't know how fast labs process things, but if it generally takes them a month, be honest. Like, hey, this is going to take a month, and I'm really sorry. As soon as I know, you'll know. You know, so I think as clear as we can be, you know, we're in such a pivotal time right now in our world. As a government steward, we really are in a hard spot, and I think it behooves us all to do the best we can and being as honest with the folks that we work with, and honest with yourself too. You know, it's no one's going into this with ill intentions. We really do want to support people, but just be as clear and candid as you can. That's my nugget there.
It's hard to add to that, but I think kind of just in general, it's this idea of how you're communicating, and everyone's kind of touched on this already. And so just remembering that beekeepers are dealing with many challenges. As you know, we're focused here today talking about bee kills, but as the presentations today and yesterday point out, there's a whole lot of other stressors that are affecting bee colonies, and that beekeepers are having to try to manage all together with everything else going on in the colony as well as out in the environment. And so just being aware of that, and knowing how you communicate with them can really make a difference. And asking those questions, listening with genuine concern, and letting them know that you are there to help them, you are a resource, and explaining what you're doing, so that they understand why you're doing what you're doing, and it's not just like government policy per se. And then reach out to other professionals. So you have, you know, your apiary inspectors. Obviously, it's great to hear that in some of the states that have presented today that there is co-investigation that happens. That's fantastic. But also, you know, a lot of states have extension specialists in beekeeping and apiculture that you can reach out to. And we also have research conferences and beekeeping conferences that you all would be welcome to join in on. And so if you want more information on that, we can definitely hook you up and invite you in.
Awesome. Well, what a great way to end this webinar. Thank you, to all of our wonderful presenters and panelists for sharing their experiences with us. We're ending right at 3 o'clock Eastern Standard Time. And to our attendees, thank you so much for coming. We appreciate your participation. And again, thanks for joining us. Everybody have a great rest of your day.